Hey, yo, what up? Am I in focus? I'm not in focus. There we go. Now I can hunch over forward and stay in focus. Yo, Lucka, how's it going? Also, Dr. Guerrero. Hello, hello. Stooge. Nice cat. Nice cat emote. Courtesy of Amethyst Makes Games. Also, Amethyst Makes Games. Hello. Do you like when I use your full username? Does that make you feel special? Will be sextuple A water. I mean, yeah, maybe. It might be pentuple. No. Septuple A water. Or it might just be A water. I don't know. I don't know. Alright, let's turn the music down a tiny bit. Also, if my stream drops out, please let me know, because my internet's... It's been raining heaps. And so my internet is very dependent on the water content in the air. Why don't I just fucking stand, bro. Just stand. Yikes. But hey, fair enough. Fair enough. Alrighty, let's jump in the Cecil. Jump in Cecil. What was I doing last time? Right, I did a little bit of fucking with the wind, didn't I? Remember when I was doing something with the wind system? Right. Yeah, I made it a thingo. A wind that can actually do, like, you know, deflection. I mean, you can see it deflecting off the edge of the simulation space, which is probably not a good thing. But yeah, so that just makes our... It actually ended up being cheaper to run using the an actual fluid sim like this for the for the wind, which is kind of... Oop, I just clicked away. Yeah, kind of funny and cool, and yeah, it fixes a few, I guess you could call them bugs. So now the wind is essentially the exact same as the water. But it isn't volume preserving at all. Which we wouldn't want it to be. That would be so cringe. Okay, so with that out of the way, what the fuggles are we duggling? What the fuggle are we duggling? Who's Dougal? Who the hell is Dougal? Okay, now if our wind goes that way and it hits another one, they'll spread out. Which is cool. Right, so what we're going to do today... What the fuck is that? Oh, that's the old water. Oh no, that's the... Yeah, that's the old new water. The new old water. Or is it? I can't tell. We're going to go to our pretty example map. And begin... So, what I wanted to do today... Actually, no. First, before we get started, I had someone ask me about what makes a good attribute system, or property manager, or property system, as in, like, you know, descriptors for things. So I think I'll answer that question first. If that person could get their notepad ready. Oh, the other thing we did last session, which was important, is we separated all of our simulation layers into separate emitters, and then they get linked using Grid 2D readers, which means that, I don't know, it for some reason I've gained a lot of performance unexplainedly. Like, doing the entire water simulation and all the other things now costs less than just doing the water simulation. So like 1.5 milliseconds. Kind of weird. But I'm not complaining. Performance is nice. Making a snack. Hell yeah. You're a snack, babe. You're a damn snack. So what we're going to do today is we are going to manage the tiles of our doodad. Now, how we do this, I'm not 100% sure. I guess first we need to, like, think using the brain. So we'll probably have a fixed tile size. Like this. Whatever this size is probably fine. What's that in, like, doodad dickos? Yeah. That's very dense. I mean, that's nice, though. It's like, what, like, fucking nearly 10 units per... I mean, yeah, I guess because it has to LOD regularly. I mean, it doesn't have to, but yeah. How the fuck do I want to go about doing this? Because I also want the... I'm just trying to think from a workflow point of view. Oh, look, there's our little busted us simulation zone. It's funny. Yeah, how we would want this to act. Oh, what? Oh, hello? Get out of there, shitlord. Poor fella. Because, yeah, for like an ocean... I guess they can just be... No, I don't necessarily want them to be square. They might have to be square volumes. Do I want each tile to have a collider? I mean, that sounds kind of... I wonder what would be more efficient. It's also like, can you visualize the collision octree? Enable collision manager. No, that's no collision pruning. Manifold. God, fuck. That's a lot of shit. Let's go Octree. No, Dump Octree elements. Debug nav. No, that's shadow visibility. Frustum cull. Use Octree. Has anyone ever looked? It probably doesn't matter. I think I'll just hook into it anyway. Oh, you're back. Hello. Okay, so what I was saying earlier for attributes. Attributes. So there are many ways to deal with attributes or properties. I call them properties. Maybe I'll rename mine to the other one. What's the other? Attributes. No, I don't like attribute though. I feel like property is a bit. Property can kind of be confusing though, because it's like, who owns this thing? Well, I guess that could be called ownership. Yeah. So, attribute system. Where do I start? Let me also put some text down. Comic Sans. Oh my god, why won't I just do the whole thing? There we go. I'm trying to think the best way to explain it. So let's say you've got a thing, right? Thing. I call mine entities. But basically a thing... I guess the way to think about attributes is that they're all descriptors. They all describe something. They describe, I guess, the state. Or not even like the state, because I guess state implies that it's, you know, like state machine. State implies exclusivity. But in games we need to describe things. Or a thing. And those things might require different adjectives, we could say. Like, this thing is heavy, or this thing is dirty, or this thing is hungry, or this thing has 5 out of 10 hit points, or this thing has a broken leg, or is depressed, or, I don't know, hates children, for example. So, the way I do it is we have a thing. Dog, it could be a tree. If you wanted to go that deep into it, you know, maybe it's like farming game where all your crops have, you know, they can be diseased, they can be watered, they could be in too much sunlight, they could be not enough sunlight. And that, you know, a lot of those things only apply to certain thingos. Like, a chair doesn't need to know, am I in sunlight or not? A chair just needs to know that every time someone sits on it, its durability goes down or something. This is very obtuse examples. So we have a thing, we're going to give it a manager just as like an easy way so that you can attach this to like any class. And you just have to give that class an interface. Interface called getManager. Getman. So that's an interface called getManager, and that will just return the attribute manager class. So whether it's a dog or a chair or a tree or a house or whatever, there's an easy way to firstly check if this thing has a manager. You know, does it implement interface? Or if you call the interface on it, so you can call an interface on any class, and if it doesn't implement the interface, it'll just return the default value. So the default value of the interface will be null. So it's either return manager or null. And then you can do an is valid, whatever. So if you were doing something like, our character is projectile vomiting everywhere. You know, they've got gastro and they're just all over the place, and you've got this vomit projectile actor. That vomit projectile actor might collide with a piece of furniture, it might collide with the floor, it might collide with another character. And so that vomit projectile is going to ask, vomit is going to call the interface on whatever it collides with. That interface will return the manager. Do static manager get if other manager interactions use public functions? Yeah. I mean, you could do that. You could use like subsystems and whatnot that would kind of automatically, you know, try and get this. But just for simplicity, we'll just go with this. So yeah, let's just. Are you following along with the vomit example, Amethyst? Characters vomiting everywhere in the house. Also, I dropped my bitrate, so it should settle down. Hopefully, it doesn't reset. Oop, my sand crabs. Okay. So vomit hits a thing and calls interface getManager. If it has the manager, then the manager will have a function called get property by tag, for example. Get property by tag, dirtiness or cleanliness or something. And it will search through all of the properties that are currently tied to that manager or that thing. It'll find the one that says cleanliness, and then we can operate on that. Increase cleanliness, decrease cleanliness. Some things might have cleanliness, other things might not have cleanliness. Maybe, if it's outside on the floor, maybe it just spawns like a vomit puddle actor if it didn't land on anything or anyone. So that would be like vomit hits the ground. Ground doesn't have a property manager, therefore, spawn vomit actor. So that could be like a fallback for that particular case. But anyway, so let's say you could use instance structures and like this. Kind of, but structs can get... I mean, yeah, you could. As a replacement for objects. I don't know if instance structs can... Can instance structs have child classes, though? Because the reason I like using objects as attributes is that those objects can then, at least in Blue, I know you can add functions to structs in C++, but in Blueprint, structs are very, you know, like read-only sort of doodads. But you could have a cleanliness property, so a human cleanliness property, when its value gets updated, it can handle changing the character's material, you know, and it would know, oh, the character's, you know, material parameter is called global cleanliness, or like whatever. But then for like a cat might have a different cleanliness, you know, attribute or property, and it knows how to handle it for a cat. And maybe, like, if you had, like, a couch, maybe the couch has multiple different material zones for when it gets dirty or broken or whatever. And so the property could handle that. All the properties would either derive from a cleanliness, you know, parent property class, or they would just have a tag called cleanliness. And you'd just make sure that, you know, you didn't have two different cleanliness properties on one thingo. So this way it's like fully modular and whatnot. The only downside would be like indirection cost. But it just depends on how many of these you're updating every frame. So it shouldn't really be that bad. Can also return data assets in functions. They can be child class, native spawn, create objects with don't canvas. Yeah, so the only thing about data assets is that they're read-only, you know, assets. So with these objects, these property objects, we can have them, like, hook into one another with, like, non-destructive modifiers, or, you know, like store a reference to, let's say, trying to think of an example. Let's say we've got a character that has a tiredness property, and then the character drinks a coffee, and so we give them the freshly caffeinated property, which that caffeinated property is going to look for tiredness, it's going to look for bladder, you know, it'll look for whatever, and then it will keep a reference to them, and there'll be a function that will be like, okay, whenever these guys get recalculated or dirtied, they need to run this guy's and that would be a two-way linkage, if it needed to be. But, well, actually, yeah, bladder would probably want to hook into that. I don't know. I'm very tired, but yeah, you'd want to run the caffeinated modifier on tiredness and bladder, and it would decide, you know, I modify tiredness by reducing the decay rate of, you know, energy, but I modify the bladder by increasing the rate that the bladder need fills up. Maybe by like a static amount, not like a multiplier. And then you can, when the caffeinated buff runs out, or maybe they throw up or something, or whatever, you can just delete this. You can remove that object entirely, and then it would, you know, it would remove itself from the list of things modifying tiredness and bladder. they would recalculate themselves to get their current value or their current rate. And then, you know, it's like non-destructive. So you never run into things like, if you... There's like some old games where some buffs are additive and others are multiplicative. And if you... I think like even fucking Skyrim runs into it. Where you know, you eat some food and it increases your health by 50 points. And then you drink another potion that increases your health by 50%. And then the food buff runs out. And then the health buff runs out. And you end up with a different base health value. Which is like, you know, silly. Very exploitable and also not very, you know, not very stable. Why not using gas? So gas relies on actors and components, which is kind of doo-doo when you are like virtualizing everything. So like when you've got things that are unloaded, so like there's no actor representing it, and therefore no components representing it, you just want to have a bunch of objects, you know, floating around in cyberspace that still represent, like let's say, yeah, it's like a life sim game, and you call up another character on the phone. Instead of having to load that character, you know, get all of their data, put all their shit in the, you know, load up the gas thing, and then modify their friendship attribute with your character. It's just a matter of like, yeah, let's just load these objects and whatnot. So yeah, they're a lot cheaper to kind of deal with. At least that's what I've found. And keep in mind, I'm not a professional. This is just my experience as someone that's done attributes at least like twice from the ground up. And I'll probably do it again in the final Prismatica refactor. But it is essentially gas. It's gas, but simpler. One thing that I do, I don't know if gas does it, because I haven't actually used gas, but I have a like a subclass of property. So there's property, prop, and there's a subclass called, I think it's called like, it's not ticking, rated? I don't know what to call it. I forget what I called it. But it's basically a property that gets added to a tick list. I guess it is just called ticking. It's a ticking property. And it has a base rate. Base rate. And it has a current rate. You know, I can just fucking use text for this. Ticking. So base rate, current rate, and then a base value and a current value. So actually, I think all of my things have these variables in them. And I don't actually differentiate them, but I would want to, yeah, probably do that in the next iteration. But essentially, the rate on every update of this property will increase the base value you know, delta time multiplied by current rate. And then the current value is like a static, you know, or not static, but it depends on the base value. So let's say we had something like tiredness, right? So we've got tiredness. The base rate is, you know, 1 or -1 tiredness per second. So -1 base rate. And so we lose 1 tiredness every second. If we are... Let's say we're exercising. Let's say our character's exercising, moving around, working, doing something that makes them tired. You know, they're not sitting on the couch. We could say that that thing modifies the rate by, you know, adding -0.5. So plus -0.5. So that would make our current rate -1.5. And so every second, we're going to decrease the base value by 1.5. And so if there was nothing modifying the base and the current value, then that would be it. The base value would equal the current value. But then let's say we drink, like, I don't know, an energy drink. And the energy drink takes the base value. So, you know, which is the what their tiredness is at, and it doubles it. So if they were like, if their energy was at 0, they'd still have 0 energy and they'd pass out. If their energy was 10, then it would go to 20%. If their energy was at 100%, then maybe it just caps at 100% or whatever. And so that's like kind of a, like, this one determines this one, and then this one has, you know, modifier. It's all interlinked. It's all... I'm probably not doing a good example of, like, explaining examples and stuff. I've got, like, graphs. Let me let me get my graphs open. Like, for my project. I guess mine's obviously more geared towards, like, you know, combat and whatnot. Where am I? Own? Where am I owned by me? Maybe it's my other account. No, it should be on Prismatic. Let's see. Why? Where's all my fingers gone? You've reached the limit of 3 editable boards. Blah, blah, blah. Where are my boards, though? Recent. No. Is it? Anyway, I appear to have lost my my old diagrams and whatnot. That's a good amethyst. I thought it was worth explaining anyway. But yeah, the gist of it is that you can add and compose and everything on the fly. So I'm just going to tell this guy to buzz off. Get out of my sand crab spot, you noob. Noob with your addy scimitar. Oh my god, fuck off. You dog! Yeah, but anyway, you want attributes and properties to be able to modify other properties non-destructively, and you want them to be able to just do... Like, if everything was sort of a hard-coded struct of just, like, you know, let's say it was like an ARPG game, and it was like, okay, let's, everything has health, it has mana, it has stamina, it has armor, it has elemental resistance, it has fire resistance, it has damage bonus against undead, it has damage bonus against animals, it has damage bonus against humanoids, it has, like, you know, all this stuff. And then you wanted to make, like, a potion that, you know, increases the damage against humans by 0.5 or something, then it's like, yeah, it gets a bit funky. And then if you start editing the struct, then it gets even funkier, because blueprint and structs don't go well together, because it's kind of cursed. But yeah, I can go over it tomorrow. My brain's not working that well either. But yeah. Some atomic structs. That's something I've never heard before. What's an atomic struct? Keep in mind, I'm not smart. Nor am I experienced. This is just like my brain, you know. By atomic structs, do you mean like structs that... I don't know. Oh, my hair is nice and dry-ish. Not really. Let me save this one. It's a good NFT. But yeah, like, I mean, you could discuss this kind of thing for like a year and still not find the perfect solution. But I think like most people should I think everyone should have a go at doing their own version of, you know, a property system. Rather than, I mean, like, gas is fine, GAS, but it's like it has a very specific use case, and like, yeah, you can change how it works and all that kind of stuff, but it's sort of like and again, I haven't used gas firsthand, but a lot of people that I've talked to about it, or that have had comments about it, have said that, like, yeah, learning all of the ins and outs of gas, all the ins and outs of gas would take as long as building your own system anyway. And, you know, if you're thinking long term, not just development of your project, but development of your skill set, then it's usually a better idea to, you know, make your own. Understand kind of why you do things a certain way, and then also for your particular project, it can, you know, make things easier and make more sense and have extra features that gas doesn't do, or get rid of dependencies that, you know, gas would impose. But yeah, I always recommend everyone have a go at doing attribute system and an ability system, which is also what gas does as well. Or not even like an ability... Well, I guess an ability system... I guess gas also... Gas deals with, like, state machine stuff, right? Like, it deals with, like, oh, we are currently attacking, therefore we can't jump. I'm pretty sure it does, like, yeah, action state as well. But yeah, that's a good project that I think everyone should at least give a crack. Anyway, enough of that boring gameplay stuff. Pfft, what the fuck is gameplay? All I know is fucking fluid simulation. It's fluid time. Let's get fluids. Let's get our brain juice flowing. Yeah? You like that one? You like the juices? You like getting juiced? Oh, now that's odd there. I wonder why... Okay, what's going on here? Is that because it is... No, that's fine. Okay. Right, it's just because it filled up too quickly. So it's got a little bit of... Oh no, that might be my fault. Ideally, it should be filling to this exact level, so that we don't get kind of bubbling, like surface tension looking shit like that. Anyway. I've had structs become corrupted a few times, so I try to avoid them if I can. It's not fun to fill out struct data again for 50 different objects. Yeah. There is, I know the exact bug that you're talking about, where you've got a struct on a thing, and you've got, like, default values filled out, and then you, like, edit the struct, and then all of a sudden all of the default values are set back to 0. And then you try and change them, but they just keep getting set back to 0. The solution, which is... The solution is replicatable. I forget how it goes, but I think you need to save the struct, close the engine, open up the project again, make a change to the struct, and then close the engine. But when it asks you, oh, do you want to also save all of these classes that implement that struct, don't save them. Just say don't save, but make sure you've saved the struct. Then open the engine again, and all of the default values should have returned, and they'll all be happy. At least that's how I've fixed it, like 100 times. It's really like it's like a known thing, but like surely I don't know. If they know that that's the solution, or if we all know that that's the solution, why can't they just automate that for it to not fuck up in the first place? It's just, I don't know. There's more important things in the engine, you know, like nanite and lumen, you know, and like megalites and metahuman and what are the other ones? I don't know. More important things than, you know, something as like minute as like using structs in Blueprint. So fucking dumb. I want to kill myself. Anyway. Ocean Manager. Okay, so I'm trying to think how to do this shizit. And let's say so we need a water body actor. We need that actor to generate these dudes, these tiles, and I'll also clean up the edging slightly. I'm just trying to think, because the water actors are gonna handle like buoyancy relevancy, right? So like, oh, we are in the ocean's, you know, bounds. Probably like here as well, honestly. You know, we're within relevancy of water. Therefore, we need to start doing queries on the water level. So that we can do, you know, physics, buoyancy, blah, blah, blah. And, you know, slow our movement speed down or make things wet. So the way that we're gonna do that is we have the... I guess the meshes themselves... I'm just trying to think, though, because people might want to do stuff like have spherical water bodies, right? So we'd want to be doing... I guess, yeah, we can have these trigger overlap. Or maybe I'd have to do, like, a different trace channel. Oh, no, we can do it by object type. We can do, like, a multi-trace. Although, would we even need to? Because our water is... No, I guess our water... Well, within relevancy is totally determined by the render target. By this guy. Like, we know what the height of the water is. Because, yeah, that's what the blue channel in here is doing. That's the foam. So I guess we don't even need to, like... Oh, forgot to fix that. I think either way it would be good to know whether we're under or over the water. I guess for the fallback stuff, it'd probably be more relevant for things that are out of scope. So we know what the water level is, because in the fallback zone, all we're doing is calculating the Gerstner the Gerstner dudes. And then that is only an offset from the water. So I guess the tiles will still need a collision to some degree. So we need bounding boxes. I guess the thing about the ocean is like... Fuck. We need to know whether something is in the ocean. Oh, we need to know if something is in the water. Or near the water, even. So, like, for a river, we have to have, you know, some doodads that go up and whatever. Although, the other thing is that... Oh, no, I guess we limit our groundwater. So, like, if there is water that isn't in a water body, you know, if it's just, like, on the terrain, like rainwater, I guess most things won't be, like, affected by it. And it will be limited to, like, what, 5 centimeters of depth, or 10 centimeters of depth? Or 10 units? It's not really I mean, it is centimeters, but it doesn't really look like it. But I'm just thinking... I think, therefore, I am. Let me think. I need to use the brain. What would be affected by, like, river overflow? Probably not much. It's probably literally just a query for, is this wet? For some things, like, you know, when we footstep, it's like, oh, what particles do we need to frick around with? You know? Which particles need fricking? Frickinization. Sorry, this is going to be a very, like, thinking-heavy stream. I guess we could turn water sensing on when it starts raining, or when the rain is past a certain point. So we would just have a, on the component that handles buoyancy. Yeah, look at this fat dude. How do you draw nice patterns to RT using Niagara? I can only find the function that draws a single pixel. Are you doing a loop somehow in Scratchpad? Yes. In here, do like a new stage. New generic emitter stage, or whatever it's called. Generic simulation stage settings. And then in here, you do iteration source, data interface. And then the data interface is either the grid system, or you can just do it directly on the render target. And that just means it will iterate. So for this function, this module, it will iterate over every pixel. And it also does... So, like, imagine your grid system as, like, an n-dimensional cube. Or not even n-dimensional. It's a 3-dimensional cube. Like, here's render target, or 2D texture. but then you can have infinite numbers of variables, you know, stacked on top of each other. That's what a Niagara grid does. It's just a per pixel save this variable, you know, save a float and a vector 3 and a vector 4 and 100 different floats, whatever. And then where the hell did my... Here it is. Then inside there, you can get the... whatever the data interface is, so usually you'd be using a grid 2D. You can get execution index to grid index, which is, if it's the top left pixel, that would be 0, 0. Or you can do execution index to unit, which returns like the UV coordinates. So the top left would be 0, 0, but the bottom right would just be 1, 1. So 0.5, 0.5 is the dead center of the render target, and that's how you can do, you know, like drawing shapes and stuff. So if you said, get the current unit, subtract 0.5, 0.5, and then got the length of that, then you would get like a circle from the center of the render target. And then you can say set render target value, and that's going to set render target value for each pixel, because you're iterating over the entire grid or the entire render target. So that's how we do that. Yeah. Because, yeah, that's like the entire backbone of this system is, you know, drawing shapes. And we do like a bunch of funky math to, like, you know, draw vector fields or draw directions or draw like omnidirectional things. And then the way that a fluid simulation works is that we, for each pixel, we look at the neighboring pixels and do something. So it's like game of life, sort of cellular automata. So like all of these pixels here only know about their up, down, left, right neighboring pixels. And the way you do that is by, you know, if I go to the wind simulation stage, we just go get the current index and then +1, -1 from the X, so that's left and right, and then +1, -1 from the Y. Although I'm doing that in... that should probably be odd numbers, actually. I'm just doing that because I want it to kind of get averages from further afield for the wind sim, just so there's a bit more diffusion. Yeah, so now we don't get as much. We do still get some crisscrossing. I wonder if that's just because of the kernel size, or if it's just because it is using the center points. No, it is just because of the way we're storing the data. So that can be 3 and 3. So yeah, that's using the and this is with a grid 2D. You could do this by like sampling the render target, but the render target in Niagara should only be the output, which is like what I do here, right? Sim to render target, get the value that I want to write for this pixel, and do the thing. And all the other stuff works in the grid, because the grid will automatically cache variables between stages. So, like here, for example, add the input to the wind system. Cool. Then in another stage after that, calculate the wind pressure which is getting the current velocity and checking where the velocities are like pushing against each other. So if the pixel above and the pixel below are pointing up this way, then that means more pressure in that spot. And then after that, we cache the pressure values so that then we can look up, down, left, right of the pressure and generate a normal map from that pressure value, and then apply that normal map as wind velocity again. And that's why if we go to wind, this is the same with like fluid or water as well, but if we look at this bit and it bumps against, well, it's kind of a shit example. What's like a good, maybe diagonal? We do this and then that. You can see that they kind of bump into each other and they go out to the side. This is a very shit example. I can't see far enough. I mean, you can see it if I just blow wind into the boundary, like this. You can see that it will kind of bounce outwards, because pressure builds up at the boundary, and then that creates a normal map, which makes it go omnidirectional, but because we've still got velocity coming in this way, it ends up just shooting out to the sides. That's like a very simple, what do you call it? I guess it's a compressible fluid simulation in this case. A lot of them will do like an iterative solver to apply velocity. Like you'll get the current pressure, and then you'll do like a blur function, but you have to iterate over it like 8 times for it to work, which means that it's way more expensive. But what I do is just let the pressure build up over multiple frames, and then, you know, as it builds up over multiple frames, the strength of the omnidirectional, you know, correction force gets higher and higher, and it just kind of figures itself out. Which is fine for stuff like wind. It's also fine for stuff like water, because the water uses, like, wherever there is pressure or convergence in the water, we just raise the height of the water. And then the height, you know, because the water is now curved like this, it generates acceleration downwards. So that's why the water levels itself out over time. Just like in real life, you know? Like it wants to reach equilibrium. But yeah, I will be, I've got a video filmed about Grid 2D basics, and then I'm going to film a video about a very simple fluid simulation. Pretty much like this one. Not this one, sorry, this one. And then maybe some more advanced videos that kind of break down the plugin and whatnot. But, yeah. So keep an eye out for them. So hopefully people will be able to recreate my plugin from scratch if they're dedicated enough. Learning so much from you, that's my job. That's my job. That's my gerb. The Turkin or gerbs. Alright, what was I talking... Right. Tile manager. So, we need a water body actor. A P-scape water body actor. I wonder if... I'm trying to think... Can you hook into the landscape brushes? You know landscape brushes? Has anyone in the chat ever made a custom landscape brush? Where you can, you know, divot the ground or something based on a spline. Because the one thing that a lot of people have said they hate about the Unreal water system is that you can't separate, or like you can't just place water down. The water has to, like, it fucks up the landscape, and it's like, ugh, it's like, yeah. And then you can't access that data at runtime. Like, it's just, it's like just thing. Land mass, that's the one. Let me have a little geese. Oh, they'd have some, some defaults, right? Critic, have you come across floating errors with RVTs? For example, I have a plane at Z150 printing to RVT, but when sampling the RVT returns 150.220. I think... I can't remember... Try turning texture compression off. It's either a resolution issue, so it's sampling... So, you know, your landscape might be like this, or your plane... Oh, no, I guess it wouldn't be a resolution issue if it's a flat plane. But the common things are inaccuracy because of resolution. So it's like, you know, here, and here, and here, and there. But you get, like... You get inaccuracy at this point and at this point, because it's all linearly interpolated. So there's resolution, which if you're using a plane, again, it probably isn't the issue. It could be compression, which you can turn off in the dude. In this guy. Height RVT. Enable texture compression off. And then the other thing that it could be is that the runtime virtual texture bounds, volume bounds, sorry. Runtime virtual texture, blah, blah, blah. The RVT might be too high. Like the height of it. As in the size of it might be too big. Because the way the RVT works is that it uses a scene capture at the highest boundary. So it does like an orthographic scene capture from the top of the RVT, and then it will do, like, you know, the distance from that point gives you the height. So if the RVT volume is like 1,000,000 units tall, it means that, you know, you've only got 32 bits or 16 bits. I don't know what the... there's no, like, thingo for it. Yeah, it just means that it's like a signal to noise. I mean, it's just like a vertical resolution thing. Because it's going to say, oh yeah, we've got like this distance. Yeah, so they're kind of the... My speech isn't working today, but that would be the only fixes, I guess. It might also even... because I'm pretty sure internally internally it gets normalized. Or like, you know, this value would be 0. Or whatever the size is. I don't know, 12,000 at this point. An assumption was the plane's not actually 0 in height. It should... It'll be using, like, a depth pass. So it should still be accurate. I think you can even... I mean, there's no real point, because you put in a pixel number. Yeah, no, yeah, it does the capture in... Actually, wait, it does the capture in pixel space. And you can add... Because I add texture into my world height stuff. If my RVT would fucking update. Can you, like, refresh, please? Where's my... That's another thing I need to fix is... I have an idea to ensure that the RVT is always in bounds. Because you can see here, it's lower resolution than down here. And that's because down here, I've got, like, a cube that is actually using the RVT. So it'll make sure that, yeah. But yeah, I add texture detail into my RVT height map. So, like, these, you know, these tiles here, which are just texture, you can do, like, height blending based on that, and also the water sim will take the tiles into account. So maybe it is... No, but if you're getting absolute world position Z, that'll be getting that position from the vertex buffer, and then... Sorry, I just clicked away from the screen. I don't know. ZLTV capture as an integer high, like total Z boundary, an entire number. Total boundary Z is an entire number. I don't know. Do you mean like from from the bottom to the top is a 0 to 1 value? Because I think that might be how it stores it internally, and then when you sample it, it like decompresses that. So it's been -2 to positive 0.2. Okay. Yeah. Yeah, I'm not super sure. Having float height may cause float precision errors. Oh, you mean like the absolute height? So like if your entire level was at like positive 1 million, but even if the RVT was, you know, really small, I think it does it relative, because it uses a scene capture. Although I guess it uses absolute world position, but doesn't the Unreal GPU stuff use 64-bit or 32-bit position stuff now? Not an entire number. Well, it should be able to unpack that when it gets sampled, because if you sample the height RVT in a material, it will return the absolute value, but I'm pretty sure when it's stored in the texture, it's a 0 to 1. But yeah, I don't know. I'm not sure what the solution is. Also, Sov, how are you doing? I love fixing all the issues in their engine plugin every time I update my Unreal. Classic Unreal. Classic Unreal tech debt issues. Landmass PTSD. So is it worth looking into or not? I like the idea of it. It'd also be nice to be like, oh, let's put a river in and then automatically populate it with like cliff, or, you know, with like the side thingos, the river bed. things. I don't know. 0x, plan to buy your plugin. Can you show me how I can use foliage interaction for the foliage from Fab or any foliage? I have a playlist on my YouTube channel for the plugin. It's in a... You'll have to go to my playlists and then go to the plugin documentation playlist, and it describes all of the foliage that I use here is from the marketplace. And it shows how to set up any foliage for use with the plugin. With the inbuilt functions, at least. If you want to make your own functions, you know. Because, like, in the end, the entire thing is just these textures. So, like, given this value, what should the foliage be doing? You know, if we are blowing it in the positive Y direction, then it should bend that way. And if the velocity is there, then we should jiggle it around and whatnot. So it is very open-ended to, like, you know, your own implementations, but I've also got my own functions, like the jiggler and the wiggler and the pusher and all those kind of things. Which are set up, yeah, in a specific way so that if you follow the guide and pivot paint them using my scripts, then it'll just work with any foliage. Only because there's no other solution. Yeah, right. Try multiplying the input by 100, sampling the RVT with divide 100, try to bypass the float. Yeah, okay. One of you might have encountered from top-down perspective, it doesn't matter since you don't see the 0.2 difference. Yeah. I mean, what's the implementation that like why does the inaccuracy matter to that degree? Not saying it doesn't matter, but you know. Original first person water post process work with the prismatic so the 0.2 is very visible with calculating the water line. Ah, right, because we're using the water height RVT. Yeah. Oh, I got an explosion. That's new. That was a wind explosion, wasn't it? Right, I definitely need to cap the wind. That was an odd one. Yeah, that would have been a divide by 0 error. Yeah, with the new update that, you know, is nearly done, the water is actually in the render target, the absolute position in 32-bit, but I guess it's reading the RVT as input anyway. So then, yeah, this B value is the absolute height of the water. So we would be using that, but I guess it would also run into that same issue. I guess the way around it would be to have like a range where the water line, you know what I mean? Rather than it being like pixel perfect water line post-process thing, give it like a range of some value, like along the clip plane. That way you'd kind of hide the inaccuracy. Maybe. I don't. I'm too dumb. I'm a silly boy. Yo, Meadow, how's it going? Nobody told me a Chad was on stream. Oops, wrong button. That's me. Having a vape belt material and my TSR anti-aliasing is causing trails along the panning material. There's no way to pass along velocity vectors or something to prevent the smear. And do you have a YouTube video out laying around? I don't. However, I think what you're looking for is the what's it called? Previous frame switch. Let me just open up a dude. With a very thick waterline. Yeah. You could also move the effect, kind of like the clip plane further out from the camera. Kind of. I don't know. So yeah, is there one that's just called velocity? No, okay, so it is previous frame switch. Where you would have the... I think this is the one used to manually provide expressions for motion vector generation caused by changes in... Oh, that's for world position offset between frames. But I think it also applies to panning. So you would have texture. You'd have to double sample it, which is kind of lame. But, you know, if it fixes the smearing, then, you know, you would have your... let's just say you're using time. And I think you can get delta. Yeah. Okay, so time minus delta. So this would be panner, time, speed 1, smack it in. Panner, time, subtract the frame time. Time, speed, whack it in. Current frame, previous frame. Chuck that into the man. Put it inside the man. And that might potentially, maybe, fix it. These mainly provide expressions for motion vector generation caused by changes in world position offset between frames. I'm like 99% sure that works in pixel space as well, not just vertex. Give that a shot. See if that works. Keep in mind, I haven't done that. I've never used that. I accept the smearing. I'm a TAA enthusiast. Also, thank you very much for the sub. Absolutely awesome. The mayor of awesome. Thank you very much. Appreciated. All good. I am a bit of an Unreal enthusiast. Sometimes. Okay, so yeah, landmass. Custom brush landmass. Erosion brush base. So these are brushes... So these blueprint ones, are they like placed down? Oh, is this gonna... okay. Well, fuck. Landmass. Unreal Engine plugins, everyone. Fuck. Why does the lighting on camera look weird? Because I don't have my key light on. My camera's at like 12,000 ISO. I've just got these tiny little colored lights on, and that's it. So my face is only being lit by the computer screen. Hence, if I go to paint and I go new project, it hurts my eyes. I've just been a bit sick the past few days, so I'm still recovering, and my eyes hurt, and it's like, I just want to sit in absolute darkness. But, yeah. It's very dark in here. It's pretty much pitch black, but my camera just gets pumped up. Giga high. It's a night vision camera. Alright, so, landmass. Out of the question. Yeah. I think I don't want to tie the rivers to any brushes like that anyway. I guess you could just use the spline. You could make I could make a child class of the river that, you know, makes it dig out and whatever. But otherwise, I just kind of like manually carving out, you know, the landscape and shit. I was also going to do a river fallback generator. Although now that I've thought about it, because I want all of the water tools to be usable for, like, procedural terrain, I don't want to do like a GPU bake, because that would just take ages and shit. So, but even a CPU one would be... Fuck, what's a good way to do it? What's a good way to asynchronously do a water simulation and then generate a spline mesh and vertex paint it to have the velocities and the foam built in? You know? Because I just want people to be able to be like, oh yeah, I'm putting a river here. And they just, what the fuck is this? Is that like an overlap? Or am I, what the fuck? Okay, whatever. Yeah, so people just put down a river and, you know, then they just click the make good button. And then it will, you know, make the river actually more physical. It'll make it conform to the landscape, and then from a distance, it will look good. Velocity would be according to slope plus river width at a given point. Well, it would be more like, you know, if I actually do my water simulation, and if the RVT would actually load before the simulation started, and we go up to this river up here. Yo, fool! Yo, what up, fool? Do you get that a lot? Maybe. How's it going? Is that still a thing? All the time. Hell yeah. So what I was just saying to a nice chatter, yeah, we would want the rivers to look like... What's actually going on here? Hello? What the fuck is that? Right, that's because... Yeah, okay. This is one of the reasons that I want the fallback to be, you know, proper. Yeah, we'd essentially want to simulate the water and then bake the result to, you know, a custom mesh, or to the vertex color of the spliny boy. So that at a distance, it would resemble this state. You know, if we look at it from over here, it's like, oh yeah, it's like, it looks pretty it doesn't look shit, at least. And then, because like currently, you know, if I just move over here, it looks like this. It looks dumb as fuck. This is just like the mesh. You know, the mesh being the mesh. So, and you know, as I move over to it, it will then become simulated. Obviously, there's a lot of spillage because it's you know, not set up very well. But yeah. So like it's pretty easy to, I mean, I say it's easy. It's pretty straightforward to, you know, get all these rivers in editor, generate, you know, a custom boundary, run a version of the water simulation in editor, and end up with a rendertage. That's not the right one. End up with a render target that says, here's the water height, here is the velocities of the water, and here is the foam of the water, and whatever. Maybe we could temporally blur the foam, because, you know, we do get nice little cascades naturally happening. And then use that, you know, just per vertex of the custom mesh. You know, offset the vert using, what's the mesh tool called again? The mesh dicker. I've forgotten it. Geometry script. The geometry script system. So we just say for all these points, you know, generate a mesh with verts at these points, triangulate it, we're good to go. So that's super easy to do in engine, or like offline, because we can do like a 2K, you know, simulation zone. Like if I do something silly, for example, and I say Prismatoscape Manager, let's do something ridiculous like this might crash the engine, actually. Let's do water. Where the Fullbox, what were you up to? Sorry, I was very distracted. I'm having a bit of a meltdown. I'm sick. I'm sick today. I've been sick for a few days, but I'm fine. Thanks for asking. Right, search thingos, water, resolution. Let's do like let's do a 4K simulation, and then our simulation simulation size world space, instead of being 4,000 units across, we would do 4,000 units. Maybe we'll multiply that by like 8. So we have 320 meters of simulation zone and whatever. Now this might crash. Okay, it's not happy. Okay, maybe. Okay. Maybe let's not do a 4K simulation. What's 4K? Maybe I went a bit overboard. 096 times 4096. Right, okay, that's 12 million. Sorry, 17 million particles per frame. Whereas currently we're doing 348 by 348. So that is 17 million divided by... Fuck, what was it? 12,000? Say 13,000. So that's 1,000 times more. So that's Okay, no, that should only be taking about 2 seconds per frame. But I think the engine just gets angry at that point. So let's let's try 2K for example. Oh, maybe it was. Yeah. Yeah, chuck it in the chat, Fullbox. I would love to see. I'll get it up on the stream. On the stream. Okay, let's not do that much. We'll go Busky. The Blue Sky abbreviation just reminds me of Esky. Right, I press play. Oh. Oh. The particles. Does that actually do 1 particle for every point? Or, no, it looks like every 10, maybe. It looks very satisfying. It's like real game, you know? Need to limit it? Yeah. It's probably a good idea. Yeah, that's dope, though. Sorry, it was a bit 100k? Yeah. You could always do, limit the amount of particles, but increase the size of them, when it's like, you know, an 100,000, you know. Just so, like, it still feels, like, really juicy. Like you're getting big numbers. Because everyone loves numbers go up, you know. I love numbers go up. I'm always numbers going up, and even when I stream, the numbers must go up. Even if it means AFKing sand crabs for 8 hours. Make some last a little longer, generate more, but over time. Yeah, like it keeps... It's like Super Mario Bros. Where, like, depending on how big your score is, it just takes ages to... Well, not... You don't want it to take ages, but yeah. It, like, does it for longer, so it feels like you're really pumping it. Right, let's put the water resolution to... Not 4K. Let's try 2K. That'll be at least... How does math work again? If you go from a 4K squared to 2K squared, what's the square root? Is it? Any idea for potential release date? Do you mean of the plugin update? Or do you mean for my game? Because my game will be a long boy. It'll be a little while. Input resolution's fine. Simulation size. Let's just go to like 4K multiplied by 4. 16K. Oh, good, fool. Have a good food. Enjoy food. Okay, at least now... Yeah, okay, so you can see that, yes, it kind of works at a higher resolution. At least we're not crashing. But the... I guess we'd use a fixed simulation step. But yeah, you could bake zones and whatever. You know, let me just put it down to 1K. I've tested 1K before, and it's not that bad, so... water. Resolution. 1K. I mean, it's still shit, but, like, not as shit. Oh, look, 1K. Is that actually at 1K? Let me just double check. Yeah, I think that's actually operating at 1K. And it's 16K size. So yeah, we are getting water simulating all the way over here. Even though we're over here. So yeah, essentially, like, yeah, now our oh, you can even see our simulation zone, because I do it on the water. So pink is fully simulated. Here's our little splishy sploshes. Just ignore the stuttering. I haven't put in the smoothed delta time yet. So fully simulated water, emulated water, and then fallback water over here. So yeah, you could totally like simulate a river with pretty decent resolution in editor. I mean, that looks perfectly fine. Yeah. So yeah, like doing that, super easy to simulate the shit. But the problem is that if you wanted to do it for like a procedural world, when you generate the world or generate a new chunk in the world or whatever, you would have to do this. I don't really know if you can do GPU simulations asynchronously. I'm sure there's like a way to kind of do it. I don't know. It's a tough one. But yeah, I'd essentially want the fallback for rivers to look pretty decent. And if the fallback is more accurate to how it's going to end up, you know, to the simulated result, it means that the edging is, you know, better. Because at the moment well, you can see here, we set the edge value to be whatever the fallback is. So if I moved over here, that should set this edge, yeah, to match the height of the fallback. And then from that point, from the edge of the simulation, it will then become simulated. And so that way, if you move from over here into the bounds there, it will... You won't notice it actually, like, turn into the simulated version. So, yeah. It's an interesting one. Like, how do we make it so that you can generate it from the what's it called? The simulated. Sorry, generate a good-looking one from the fallback simulation. I was thinking maybe I could do like a sphere marching, like on the CPU. Can you do asynchronous traces? Can you access collision stuff asynchronously, like on another thread? Any traces in the chat? Right, let's go back to our tiny baby little 384. And our radius is going to be 4K. Nice. Eric, just love your landscape and art style all these years. Something about it really made me fall in love with it all. You come a long way, brother. Thank you. I enjoy it as well. I've done it recommended, but it works. Okay. The other thing I could do is... No, I'd have to do callbacks to the RVT. No, I think I'd want to use real thingo. What do you want? Function that made X traces per frame when it was finished. Export the data. Totally not. Yeah. So like a staggered trace sample. That would be my other option. Is like, oh yeah, let's limit it to 100 operations per frame, and then compile an array. And then, yeah. Also, I don't know why this has gone this color. I think the wind is doing something naughty. It's because I've got something open that shouldn't be. It would be the water render target. Why are you that size? That should not be that size. Why would it be that size? When did I set it to 512? Wave RT 512. Why are you 512? Who did that? Who did this to you? Prismatiscape Manager, BP. Right, it would be because we've got the thing in here. Main sim grids. Can I make this inactive in editor? Wait for compilation on activate. Auto activate? Maybe fuck off. What about editor? Is editor only? I don't fucking know. Just stop doing this. No, stop it. No, that's bad. Oh, you know what it could be? I am manually setting the resolution of the render targets, but I don't need to anymore because the grid system is supposed to do that now. So that would just be in initialize, set initial params, here, resize, render target, no more. You're banned. Render target banned. Let me also just set the default. Well, no, it is set to... It should be set to 384. Yeah. Yep. Yo, my attack level just went up. Pog. Welcome back, fool. Welcome back, fool. Okay, so it's not activating anymore, so I do need to actually activate. Well, what if I do all this shit, then I wait for it, activate, bam, activate and reset. Why the fuck not? Oh wait, that's no, piss off. No, okay, that probably is it. Let's activate and reset. Whatever. Do your worst. I should probably also... I think when you enable ticking... function is registered, modifies the tick function. I wonder if this waits for the next frame to start. It's not relevant, but can anyone confirm or deny if you set tick enabled, does it wait? Does it fire off the tick function immediately when this is called? Or will it wait for the next frame? Or... fuck, I don't know. Is begin play called before tick? I mean, it would have to be for most things, but what if it... I'm guessing everything's begin play is called before the tick array gets ticked through. I don't fucking know. This should be fine either way. So now I'm manually enabling the dude. I might even put this delay to like 2 seconds so that the fucking RVT can sort its shit out. 1, 2... Yeah, now it isn't doing that divide by 0 glitch because the RVT is happy. It has its values. Now we're getting all of our edge data, our edging data. Cool. It feels a bit laggy. Why are you... No, we're at 1.5... yeah, 1.5 milliseconds. That's fine. Yeah, I'm always confused when I work. Actually, do you guys want to see something cool? Let me do a thing. I'll do a thing for you all. I'll do a little party trick. This is my fun party trick. Oh my god, they're... Okay, there. Oh, it's raining. This is my, like, 10,000 particles per second buoyancy thing. It's quite swag. Let me go over this way. Let's go to the beach. Let's go to the beach. Let's go get away. Something say... something wanna say. Starships were meant to fly. Reach up and touch the sky. Let's go to manager. And we'll go like a bit... Yeah, a bit darker. Like just, yeah. Ooh, it's juicy. We're juicing. We're getting juiced. Oh, fuck. Sorry. Rest in peace, bitrate. This is actually how I'll be handling particles as well. For some of the, like, the crashing waves and stuff. Like, rolling waves. Obviously not with this many. They'll be, like, way bigger. They'll be, like, general kind of foam doodads, but... It's pretty cool. But the idea is that, like... Instead of force spawning particles everywhere, you know, 10,000 times a second, I'll just spawn particles at random locations and just let them float around. And then they'll get pushed along by the waves, and then they coalesce where they're needed the most. Like, they just naturally fall into the proper position that they need to be in. And then, you know, given their current velocity and whatever, and whether they're on, like, a foamy section, you know, increase their opacity if they're on foam, and then we just kind of get the splashies. Get all the splashos. Or for aesthetic or ties in mechanics of the game somehow. Both. But it does tie in with my game. But a lot of this is for just the plugin. It's for sales, you know? It's for the wow factor. And the I guess the marketing. Because the plugin already sells very well without the water. Just with, like, the foliage and the wind and the, you know, the trampling stuff. This is what the plugin originally was. But then the water is just another layer on top of that. That can all, you know, work together. Like, you can see the water is dicking around with the foliage. And the foliage is all like, stateless GPU bullshit. Microplastics, true. True. But yeah, so it's a local wind and trample simulation. Per blade of grass interaction and whatever. Breath of the Wild, God of War type bullshit. But then I was like, you know what? I need water at some point, and I want the ocean to look nice, and I want the rivers to look nice. I think rivers are probably the hardest thing, or like creeks are the hardest thing to get looking nice in games. For stuff like oceans, you can just, this is all just a deterministic shader. So, like, it's not interactive at all. It doesn't loop, but it's time dependent or time reliant. But then, yeah, rivers are a bit different. And then I was like, you know what, it should all be interactive. Like, we want to be able to, run and, like, splash water around and whatever. So it kind of just became a whole thing. But in my game, at least, it is actually mechanically significant because... So my game's very... I guess you could call it like a... You could say it has survival elements, right? So it's an adventure simulator, like fantasy adventure, but also a simulation survival game. It's pretty much like if you were like isekai'd, right? If you were just dropped in a new world, not of the Amazon games type, but if you were just dropped in this new foreign world with all its own rules and its own physics and whatever, what would you do? How would you sort of make your way in that world? And everything's simulated. All of the characters will have, like, the same agency as the player, so there's no real distinction between NPC and player character other than the fact that the player controls the player character. But then obviously the weather plays a big factor in traversal. And so, for example, it might start raining really heavily, and then all of a sudden, that little stream that you crossed earlier, you might not be able to like cross that because it's filled up with water, and you're wearing full plate armor, and you either don't want your armor to get rusty, or you literally can't swim with all your armor on. So then it just becomes a matter of, okay, well, should I dig a hole and stash all of my armor in a hole, or should I try and swim through it and get swept away by the current? Maybe. Should I try and build a bridge over it? Should I just keep following it along until I find, a bridge? But then what if that bridge is manned by bandits, or it's like, someone's tolling the bridge? So yeah, weather is there to kind of like spice shit up, and water is kind of a part of that. So things like tides going up and down, and you can get to this island, but only when the tide's low, or you could sail to it when the tide's up or whatever. But yeah, just like a lot of... It's basically like shit goes wrong, the game. Let me just find the... Where's my frickin' simulation class? Here we go. Figure out how to use things to your advantage. Yeah, exactly. So it's kind of like if you were playing Dwarf Fortress, but you are one person. It's like a third-person Dwarf Fortress, top-down. It's very Exanima inspired. I like to call it Exanima without the jank, because it's just WASD, like camera relative controls, rather than the kind of like vehicular controls of Exanima. And like Exanima's fully physical driven, whereas I'll show in a sec, but do I have the handle rain? I do have handle rain. So this is like rain. This is it raining. Or acting as though it's raining. There isn't actually rain happening, but if we go to the render targets, then you'll see water, RT, da-da-da. So yeah, to make it rain, we just set the minimum water level to like 0.01, and then it just naturally like coalesces into, you know, divots and whatnot. So like if I went, I guess I could move up here. So yeah, even when it rains, it could change shit up. You know, you'll step in puddles, you'll step in little thingos. The grass gets flattened by the running water, which is just a funny little doodad. I can blow the water around with my farts. I can fart the water around everywhere. But yeah, it'll get even more. It's just like I'm just trying to have, you know, like with like AI learning models and shit. And it's pretty much just a matter of there are so many variables that something happens on the other side. It's just a matter of like how many fucking, you know, different things can happen. That's kind of what the game will be like. There'll just be like so many vectors of things that can go wrong or can go right. And that is the gameplay. Like it kind of just, the game makes itself in the end. At least that's the intent. And it sounds really smart. And I'm not that smart. But it's you know, that's the end goal. But yeah, the thing, so Exanima does fully simulated like character bodies, which just ends up being real kind of jank. So my approach is, oh god, wrong button. To represent the character using like a ball bot. Like a very like rigid body approximated character. And so this is like an actual self-balancing little setup that I've got going. And then the character's, you know, represented by a mesh. So the mesh doesn't have collision. But it means you get like some nice, like, you know, you get all the, I guess it's technically primary motion. But the main point was to, yeah, have it be physically represented so that, like, if I jumped on top of, let's say I jumped on top of this thing. Oh, wait, no, that's not me. Where? Oh, I'm here. My bad. You know what? You can be on there with a friend. Yeah, so I can, like, kind of if I move this way, it'll exert a like within the physics engine, a force on this kind of tower. So it's kind of all about like two-way physics interaction. That's why I went to this extent. But yeah, I should be able to... Oh. Nice. Well, I'm fucked. Yeah, like, if I try and, like, jump off here... I slipped. Yeah, so this is still experimental, but... I don't know. I think the ball works really good for running. I might move to, like, a foot simulation for anything that isn't running. But it's basically just a suspended cylinder balancing on a ball. And it's like, you know, there's no jumping animation, but it doesn't even need it. I mean, it does, but, you know. Oop. Yeah, that's just another bullshit thing that... If you've been here before, you know that this is just like random dumb bullshit, the stream. So yeah, that's another one of my silly little things. But the idea, again, is to just introduce, you know, lots of different vectors for gameplay. Like, you know, you're wearing leather shoes without soles, and you're walking on, you know, wet rocks. Well, you know, basically fall over and eat shit. Or maybe you've got grippy boots, but they got damaged. You know, maybe you've been walking too long, you haven't repaired your boots, and then all of a sudden you start slipping over. Fall down a cliff, break all your bones, need to amputate your leg, and then you can't get another leg until you get to the next town, when you go to the body shop. Yeah. Yep, anyway, I need to pee, so I'll be right back. All right, I'm back. Velocity, I'm doing good. I'm a bit sick, but I'm well. Frankie, does a grass safe flight if you walk in a simulation range, or they reset to default? Like, example, if you hide something, try to find the same place again, like lost squirrel, look for his nuts. Yeah, so that's one thing that I've kind of got ideas for how to handle that kind of thing. Let me just turn these glowy particles off. Yeah, currently if you flatten the grass and then walk away, the grass will unflatten. And then... Well, hold on. My bloody control scheme's so balked. Yeah, if you move back, the grass will be unflattened. So the grass flattening and stuff like, you know, trails in the sand and all that kind of stuff are not handled currently. However, I might have a system, because I think I'm going to need a kind of landscape data RVT, runtime virtual texture. And I was thinking that I might let certain characters basically just take their position, take their location, you know, every so often, and create like a footprint spline. And then you could either sample that directly, or you could feed that in to the edges of the simulation zone. So that, you know, let's say I had like, yeah, some footprints that look like this, whatever. While you're in the simulation zone, you wouldn't see that being drawn, but it would exist, you know. It would exist. And then when you go back to that point, it would sample at the edges of the simulation that RVT. And then, you know, as the pixels get offset and whatever, it would just appear as like a kind of default. It's the same way that the water works, right? Like the water back here, this is all just fallback water. So this is non-simulated water. But then as I move to the left, you can see that it becomes simulated. It's driven by the edge values, and for some reason there's a bit of a mismatch at the moment. But that... Oh no, you know what? That's because I'm doing rain. Hold on. That's because the rain isn't set up properly, and it just limits the depth of the water to be 5 units. So yeah, now if I go away, reset the water, and then I come back, and it's like, oh yeah, cool, like there's the water, it, you know, blends into the simulated range and whatever. It's a bit fucked, but, you know. I don't know what is adding... Maybe that's the RVT inaccuracy at work. Potentially. But yeah, I could essentially do the same thing for the grass trampling and also, you know, like the sand and the snow, you know, trails and whatnot. It would still mean that you wouldn't see them outside of the simulation range, and I don't think I'd want to be... well, no, I guess the grass samples the RVT anyway, because it needs the color of the landscape. So I guess in my case, it wouldn't be too bad if I was using the same RVT. But then the normal, the roughness, specular, blah, blah, blah. I don't know. I'd have to check. Hopefully they optimize RVTs in the future, like, so you can have shared RVT coordinates, so you don't have to, like, unpack all of the, you know, sample the tiles and stuff. Even, like, it just shits me. Because RVTs are, like, so good. But if you've got, let's say I've got 2 RVTs, and most of the shader cost of sampling the RVTs comes from, you know, accessing the tiles at this location and then stitching them together and whatever. But even if you have multiple RVTs that have the exact same resolution, exact same coordinates, exact same everything, it still does that unpacking, you know, for each RVT. They don't get, like, that operation doesn't get batched. So the cost of sampling multiple RVTs is linear rather than, you know, for example, let's say you've got like 8 textures, but your what's it called? Your UV coordinates. Let's say you've got like a texture bombing, you know, UV function. All of those 8 textures can share that UV coordinate calculation. So that only gets calculated once, and then the textures get sampled super easy. For RVTs, it can't share the sampling, you know, UV coordinate stuff, which is just dumb, because like 99% of the time, whenever you're using a landscape color RVT so that the grass can be the same color as the landscape, which I've forgotten to sample a lower MIP level because I'm silly. Grass. Fuck, what's it called? Peascape grass for level. Let's go down to number 3. There we go. Now it's nice and blurred out. Dank. Yeah, that's good, that's good. Yeah, so I don't know. Yeah, whenever you're using a landscape, you know, color and normals and whatever for doing like blending, like for example, this mesh gets blended into the landscape, so you can't really tell where it starts and ends because the normals get blended. You can kind of tell because there's a resolution mismatch, but yeah, usually whenever you're doing that, you're also sampling the height RVT of the landscape. So it's kind of just like, well, why not? And they always have the same location and resolution, and it's just super annoying. Very annoying. All right, let's get back on track. It's been 2.5 hours, and I have not done anything. Managers. Water managers. We need to water. Just back looking for our next project. Hell yeah. I'm glad. I'm glad, and thank you. And I hope you're looking forward to this update. It's going to be a banger. It's going to be a bangerang. If I can get it finished. I was supposed to finish it by the end of the month, so I've got 3 days left. 3 days left, and then I quit GameDev. Forever. So what? Okay, it's called New Water. Peascape River Spline. That should probably derive from... Let's make a new actor. Peascape Water Actor. Right, and this is just our base fella. What functions does our base water actor need? It will need a function. I don't know. Gonna be a kangaroo farmer after that. I'm actually already sitting on a herd of about like 150 kangaroos, but they keep jumping over the fences. So they need to be... Someone needs to come out and take care of them. And by by take care of them, I mean take care of them like in an American sort of way, you know? Is the foliage interaction getting any huge updates? Not really, just I've changed how the wind operates. The wind now uses like a compressible fluid sim instead of the old version. Although I do have... I've kept the legacy version. But this version will allow for things like wind kind of like bouncing off and around obstacles. So if you've got a house and there's wind, it'll like hit the wall and kind of like, you know, poof around it. And it's also cheaper to run as well. But the actual interaction of that with the foliage isn't any different. It's just sample render target that says wind velocity and blah, blah, blah. But yeah, it's a lot more like windy feeling. But that's the only change to the foliage. Oh, and also the water. The water affects the foliage now. You can see that the water, you know, zhuzhing the foliage around. Which I think it did anyway, but you had to actually sample the water in the foliage shader. But now it's just a case of the water actually draws to the deform simulation. So it ends up being cheaper for the foliage. For the foliage shader. Because, yeah, the water will actually do its thing now. Yeah. Yeah, my drunk. Sorry, I was going to, what's it called? I was about to, like, shout you out, and then I got really distracted, and, how was the stream? What were you working on? And how are you? How's it going? Actually, you're probably a good person to ask. Is it possible to do asynchronous line traces? Like query collision and physics and stuff on a different thread? Because I've just been thinking about I've been thinking about procedural worlds and generating like a nice fallback mesh for the rivers. And I was thinking instead of doing a GPU simulation, I might do like a marching, kind of like a marching sphere trace type dealio. Or like, you know, lots of line traces to check like, oh, where would the water be, and just do like a kind of like a course sort of, you know, follow the normals of the thing and just like cascade a bunch of thingos down. We are suing? Oh shit. No, I got it. You are using the plugin. Work on my own server. I wonder if I'm getting something wrong. That's exactly what I expected. Sim also vanish blur fuss on low res than high res grid. If you're doing Eulerian or Eulerian No, Lagrangian advection, where very fancy. Ooh, Lagrangian advection scheme, where you get the velocity, and then you do a backward, UV offset and inherit that velocity kind of thing. And that's how your values are like dissipating or like blurring, then yes, I think, because the interpolation to like the lower values, something, yeah. But if it's just a case of like I'm taking the current thing and multiplying it by the 1 minus of delta time, that shouldn't be affected by the resolution. But yeah, I guess the advection, the advection can be affected by that, is what I'm trying to say. In my head, I'm trying to think why. Are you doing when you get the advection vector, are you just getting the middle value, or are you doing like a kernel, like an up, down, left, right average, or up, down, left, right, center average? But yeah, I think in general, just the middle. You try doing an up, down, left, right. Up, down, left, right, and middle, and then divided by 5. And see if that does anything. Anything to, make it any better. But I think in general, the theory is kind of like, if your resolution is lower, let's say I've got like this many fellas, and let's say I'm like, I've got an input right here, and it's like, okay, like this is going like this. If I do advection, Lagrangian advection from here, it might backtrace to like, here or whatever, which is just this value, but, that's 0. So it'll essentially like, because of the linear interpolation, it'll essentially halve its own value. The other thing with the advection, if you're only doing the middle value, is that this one here, if this is 0 and this has velocity in it, this one won't inherit any of this velocity. Like, this will just trace against itself and not gain any stuff. So, like, doing a kernel can help with that. Although, if you're doing, like, a pressure correction step, then you don't really have to worry about that too much, because this will then get pressure build up, and then you'll do a correction, normal map outward thinger. Where was I going with this? Right, so if we doubled the resolution and we did an input, doubled the resolution in all thingos, and our input now, takes up these thingos. These ones will trace back to here and, pretty much inherit the full thinger. So these two will remain at like full strength. They're not gonna like decay as fast. And then, you know, these ones, you know, might decay, but you've still got full values up in the front of like a you know, a velocity front. So yeah, I think as you get like imagine if you only had 4 pixels, like this was the whole simulation space, and you know, you start adding velocity to this cell, like regardless of what happens, it's going to be like interpolating against a lot of empty values and whatnot. So I think it just naturally happens if the resolution's lower. I don't know if there is any workaround to it. I guess in the pressure correction stage, you should be factoring in the cell size. So the number of cells divided by, you know, the world space of it. But yeah, several each cell 4 times with cell offset, get all corners. Yeah. With a full cell offset. So in my doodad, presuming that you're using Niagara grid, it's just a case of doing get the current index and then just add 1, subtract 1 for the x, and then add 1, subtract 1 for the y, and then chuck them all together and get the average. For the water, I don't do that, but for the wind, I do that. But yeah, I guess the other thing you could do is like not worry about it too much. Or kind of tune it to, you know, whatever resolution you end up with. But I guess if you're making it for like a kind of open-ended system, then you want it to work with, you know, all scales and whatnot. But yeah, using that advection scheme always results in like blurring. And the bigger the cells are, the more that blur will kind of propagate. Because again, like if you think about it, that's not paint? Paint. Is that paint? It is. Okay, where'd the thing go? Yeah, like if you, let's say you blurred something 0.1 per frame, if there were more values, you know, this one would leak into that one, and then this one would leak into that one, and then this one would, you know, leak and whatever. Even if it was scaled by the cell size, because even if you're taking like 0.1 of the current value and moving it over to there, it means then on the next frame, this one is going to get 0.01 of this, you know, original value. But, you know, if there was only 4 cells, then even if you'd scaled it by the size, it just means that this whole thing is going to get 0.01 from the one here, and it's a bit funky. It's just kind of one of the quirks of doing, like, you know, a grid. Like, because obviously in real life, nothing is a grid. Everything is like molecules and shit. But yeah, it's I hope you figure it out. Right, water actor. let's do... Trying to think whether I... Let's just keep that as its class. And let's go to our new water. And we'll make a new folder called water actors. Yeah. Water actors. Peacegate water actor. We'll get river spline. We'll get wave mask as well in there because that's actually relevant. So we're going to move them into here. Also, V Caca de Pero. Thank you very much for the sub, you absolute giga. Geiger Chad. When do we get molecule-based game? I mean, if you let me cook for like, you know, another 10 years, maybe, you know, I could make it. When are we gonna get molecular? Actually, some people have made like fractal voxel engines, which can probably do that. Maybe. How do tiled sims work in your method? Good question. Do you mean like so I have a tiled FFT. We've got Ocean Manager, and I turn our waves down. And we go down to the macro waves. I might put these up the top. Anyway, this is a tiled flipbook of an FFT simulation. And you can see it works fine. And the water simulation will... It basically just runs the same tiled simulation. It's a little bit foamier. Oops. So it just runs the same thing, but in the grid system. And then uses that as input to the simulation. So it works, you know, pretty well. Although it is very foamy. Maybe I should tune that down. Height, this one. It's amplitude. Yeah. There we go. It's still a bit. Ah, right. All good. Thank you very much. I appreciate it. And yeah, I'm all about free knowledge. I am all about freedom of knowledge. I don't like gatekeeping. I love when I love when all the particles get like shot up in the air from the waves doing wave things. So dope. Sometimes I impress myself. Whoa. Now we're roiling. Nice. I haven't tried the particles. Silly amounts. It's very funny. Oh, look, we got little baby shore breakers. Nice. They're just juicing around. See, that's kind of accidental. But, I mean, it does look nice. I mean, it looks... It's physics, you know. Physics does its thing. I think once I have these particles working... I think the particles will make it look like... Yeah, see, like that, like that. Like, it'll make it look like the wave is flipping over. Because that's one of the main things about 2.5D water simulation, is that water can't overlap itself, because it's just a height field. But with these particles, right, the particles can get buoyancied up and then shot over that way. Kind of dope. I was thinking of maybe trying to use, like, ribbon particles, right? Ribbon particles that do this. And the ribbon particles use the single layer water material. That way it would kind of be like a continuous... Because the single layer water, you can have overlapping tiles, but it will only show the one on top. Because it gets rendered in its own Z-pass and shit. You know what I'm saying? I don't know. Rooms get really... Yeah. I might just try, like, maybe hiding it with... hiding it just with lots of foam. Just FOMO particles. Let's get some juices. Some real juicy boys. Ooh. Oof. Sorry, I just need to click on my RuneScape character. This foam in general feels a lot more natural. Yeah. I agree. Although, it depends. If it's really windy, then there's a lot of foam, but... Where's it enough? Yeah, exactly. Yeah, a lot of it would depend on, like, the wind level and whatnot. But yeah, this is like a pretty bare bones Gerstner. I'm only doing 4 Gerstner waves for the directional waves. But then you can see they kind of like, you know, this is not really how waves work. But I do like a location-based time distortion so that they get like lots of interference and whatnot. You can't really tell when you're near them. It kind of just looks like Gerstner waves in every direction. But then on top of that, we do an FFT to kind of break them up a bit. You know? GB rooms now, so... Yeah, that's true. Yeah, this can only actually work with GPU particles as well. The CPU... Anything CPU side will have to use, like, buoyancy fellas. What are they called? Pontoons that do, like, an asynchronous GPU readback. Frostcore. Is there option to flip UVs on import? That's a good question, because in Blender, I know that UVs go from bottom left to top right, but in Unreal, it goes from top left to bottom right. So one of the things is flipped. So there probably is some kind of option. Because yeah, if you go in Blender and you like, you know, set the position of the 2D cursor in the UV editor, yeah, I know that it's different to Unreal. So that is likely a thing. How do we, like... I might categorize these to be, like, main shit. Can you... No, you can't... it's so lame. I wish you could set a... like a variable priority thinger. Do nothing outside of UE differently, just re-import the mesh from UE. Yeah. Yeah, yeah. Look, that's just Unreal things, honestly. That's just how it goes. Category main params. Main params. Micro. Omni waves amplitude. You go in the main params. The amplitude. Main params. Probably the deep and the shore multiplier, I guess. But then they're gonna... No, you know what? Let's go secondary params for that. Amplitude array, length array. They're all secondary. Distortion, secondary. Shore wavelength, amplitudes array, secondary. Tide offset. That should be a main param. But it goes in the middle! You've been demoted. Anyway, let's get back to work. So, the water actor. How do we want this to work? This is where, like, the user experience comes into play. Do I have to refresh that for that to... Let's go ocean. Fuck, ocean. Piece of ocean. Dude. Ocean... Okay, but why are they not in... Fuck. It's because they're... Huh? Oh my god, they're all the fucking way down here. Oh my god. Fuck you. I should have just added a lowercase a to the variables instead of fucking with it. Whatever. I want to die. Right, so let's say I am a game developer. Let's pretend for a second that I'm a game developer. How would I want to define my ocean? Probably with a bounding box, right? I just want to be like, yep, let's do bounding box, and then it would spawn all of our ocean tiles wherever the fuck they needed to be. You know, in a nice little grid, no rotations, no nothing. Same with lakes. I'd probably be like, oh yeah, let's put a lake. For something like a lake, it's a bit weirder because lakes can be really stupid shapes. They might be a spline. Or would that just be a collection of boxes? You know what I mean? Although for like big lakes, I was thinking we'd do some like shore waves. That's probably just distance field based though. It doesn't matter for buoyancy. It depends on the size of the lake. And then we'd have to put down our water modifiers. Hum. Hum. Why is that one not... I've set that to be... Oh, right, because it's inland. Yeah, that makes sense. Right, because it's within our thinger. Our shoreline boundary. Ooh. Anything in the center of this doesn't get the directional buoys. But it does get the omni buoys. So if that was giga high. Let me turn these guys down to 0-ish. So we have these guys up full. And then this guy zoop, is saying, yeah. This adjusts the intensity of those types of waves on a lake. So if this is a pond and it's really windy, the pond shouldn't really be like, you know what I mean? But if this is like a big ass lake, then we might want it to do this when it's windy. You know what I'm saying? Just a point sphere, center of the lake, let the script detect the shores, generate grid. I like that a lot. Yeah. Yeah. Just like flood fill tiles at this height. And then if the lake dries up, it's just a Z offset. Yeah, I mean that's good. That's some good shit. Water Unreal's water plugging lets you generate lakes right when that approach by useful use them. It depends on the method. Because I want mine to be runtime friendly. So like if you're generating a world on the fly, then it should be allowed to like, it should still work. We shouldn't have to like, yeah, I know like a lot of Unreal's procedural stuff is very like you know, editor only shenanigans. The other thing is, if anyone... Here's... Let me explain how I want the water... like, the reason that I want a water well, one of the reasons I want a water manager is that I don't want to do the kind of, like, fucky sort of... You know, that, like, procedural mesh bullshit that they do in the water plugin where it's like, you know, it's cool and it's like, it's tessellated and it like dynamically tessellates as you move away from it and shit. I mean, like, yeah, cool. But like, but this is also fine. You know, I don't mind tiles that have a tiny bit of overlap so that, you know, LODs can exist. What's this big... Oh, that's the dude. The coastline. Let's hide you for a sec. Yeah, a tiny bit of overlap. Because we're using single layer water anyway, so it doesn't really matter. I guess if you were using translucency, then this method would, you know, fall apart. But, again, I just... You know, instance meshes. Cool. So the idea is that in the orange zone, so near to the player, none of the blue stuff, none of the blue shader code needs to be computed. We don't have to run the flipbook in the shader. We don't have to run the Gerstner waves in the shader because we're already doing that in our render targets. So all that the shader needs in this zone is just sampling 2 textures, and it does its WPO based on that. So it's like giga cheap for the shader, which is nice. And then at a distance, we have, you know, the fallback stuff. So my question is, if I have all these tiles and their instant static meshes, I'm going to need to have a material swap out. But I'm just thinking I don't actually want to, like, delete and create instant static mesh instances, because then, you know, when you, like, remove shit, it has to, like, you know, update everything in that instant static mesh. So I'm wondering if anyone has any experience with instant static mesh management, and how I should go about that. Because I'm gonna need... And also, do I need to, like, subdivide... Like, do instant static meshes cull efficiently? Or is it better to, like, break it up into, you know, groups of 1,000? Or, like, any advice like that would be super helpful, because I have no idea. Scale to 0, that's something I thought about. I guess if I scaled it to 0, then it would then turn into LOD number fucking 12 or whatever, which is literally just a flat plane. I wonder, can you set an LOD to be an empty mesh? Because if it was scaled to 0, you'd still be processing the vertex shader. Although it would probably cull itself at that point. I don't know. Use a lot of items, yeah, break them up in groups of 1,000 to dissipate performance instead of updating them. Gotcha. Well, yeah, my idea, if it was like a giga... Let's say the ocean was one big instant static mesh collection. And we're moving... Let's say we're moving around through the ocean. And so we want to swap out the material. And therefore, you know, swapping out the... If you change the... If you change the like, let's say I was, like, just moving them around. If you change the location or scale of an instance, does it have to send through the entire table again to the GPU? Or can it just say, update this index? You know, update the transform on the GPU in that doodad. Like, does it... Yeah, if I move or scale or rotate one instance, does that cause, like, a full refresh? Or is it only when you, like, add or remove them? Updates the whole thing. Right. Okay. How does it handle... Because I know instant static meshes can use LODs. And also, LODs can have material swap outs. The only problem is that LODs are based on screen percentage, not distance. If it was based on distance, I could rely on the LODs to swap the material to the fallback material type. Because I could just say, oh yeah, when we're at this distance, then this is where LOD 8 starts, and LOD 8 and beyond use a different doodad. So he's LOD... Yeah. That's true, Kex. I do know that little hack. Divide by 0. Yeah. I don't know if it stops the processing of the vertex shader, but I know that it would cull, because obviously if you divide WPO by 0, then it's not going to process the pixel shader because the geometry disappears. But a lot of this stuff is the vertex shader, you know, like the WPO and whatnot. Yeah, I'm just trying to figure out how I can do a material swap out for the dudes. But again, like, the LODs can do that with ISM. Like, if I go to the copyrighted subdivided plane, and if I actually gave that a material, and then I could say, oh, material slot, new material slot, you know, tutorial ribbon material, and then LOD custom, LODs nuts, LOD 7. Hold on. Where's the... How do you determine the material stuff? Reduction settings. I made a new slot. Save. LOD 1 material. LOD 2. Ah, right, sections, material, blah, blah, blah. Okay, so if I go to LOD 7... Well, what's the last one? Yeah, 7... Probably... LOD 7, sections, you use the other guy. So now these ones are all changing out to that. But again, it's based on screen size, which isn't reliable because if we zoom in, you know, we might want it to be, yeah, like full geometry, but we want it to use the fallback material. So, I don't know. Reuse instances instead of removing them. Yeah. Well, yeah, I guess maybe then the solution... I don't want to do, like, hierarchical doodads. I just want it to be simple. I just want it to be simple. Simple and easy and cool. I wonder, can you make the... No, that's distance fields. Auto compute distances. No, you can't do it there. I wonder if you can do it in the instance static mesh settings to make the LODs distance based rather than thingo based. But that would also mean, like, if you look through a telescope and you looked at the water over there, it would be low poly water. Although, like, Do we even fucking care? Question mark? I don't know. No, I guess if you set visibility on an instance. Let me check. Smasgate content, new water. Water actors. We'll just jump in here. We'll give this guy an instance. Static mesh. Can we get visibility? That's set visibility on this component, isn't it? Yeah. Visibility. Get visible. Let's just go instance. Add instance, batch update instances, transform, batch update instances. Huh? Yeah, the same thing. Clear instances, hit cull distances, instance count, instance transform, overlapping box. LED distance scale? That's the current LED scale. Remove set cull distance. No, that's for. Moving player's vision closer to the view. Yeah, that's true. LED distance scale. What do you mean? Custom data value. Custom data floats. Update transform. Read the value of variable instance LED distance scale. Scale applied. Change the computation of LED distances when using static mesh screen sizes. Smaller values may change earlier. Can this have... My throat's getting very scritchy. Pardon me. Can this guy use LOD? What have you got? Use GPU LED selection. If true, this component will use GPU LED selection. So that GPU LED selection probably removes that update having to take place from the CPU to the GPU. Because if it was getting updated on the CPU, then the LED, the mesh changed. Then it would have to tell it all of the shit. For a force LOD model, no, because again it's GPU LED selection. That's gonna use GPU bounds and shit. Never distance call allowed to detail mode. Raw distance. Override min LOD, no. I wonder... No, that would cause an update. Scale applied to the change the computation of LOD distances when using the static mesh screen sizes. Smaller values make LED transitions earlier. Right. So that's just a multiplier for the screen size. Ugh. I just want to fucking... Screen? Nope. Distance? Instance LEDs, scale, start and end cull, lighting, rendering, WPO disable distance. No, LOD, min draw, design max draw distance, never cull. Allow cull distance volume, distance multiply, no. Hum. Yeah, because we'd want to... I guess if we have to manually swap the material out, not on the GPU, then if they were in chunks, then we'd only ever be... Well, it would be a trade-off between we would have more draw calls, because we'd have, you know, maybe 10 by 10 chunks of the water tiles. But then when we swap the material out, it would... Ooh, well, Yeah, no, I'd want to do individual tiles, because... Like, the simulation distance is, well, by default, only like 40 meters. 40 meters wide. So if I, like, jump here, then we have our yellow zone, pink zone, blue zone. And a lot of fucking particles just chilling. Let me, This is also still okay performance? Yeah. But, like, I just don't like the idea of, like, hitching. Like, even if it's not noticeable, it's still... If enough things that happen on one frame all happen to line up, then it's, like, frame instability and you know... I don't like the idea of it. That's funny. Ooh. I need to pee. BRB. They call me the biscuit dipper. Alright, well, I think for now, maybe we'll just sit on that issue for now. Not worry about it too much. I think for now, we'll just work on getting the ocean existing. Because, yeah, we would likely want to do the exact same thing for the rivers and for the lakes and all that kind of stuff. We'd want to swap the material out with the low-cost one. The low-cost material near us and the higher-cost one further away, where it's, you know, a lower LOD and it isn't as much of a performance hit, and it also needs to be, you know, not non-tiling, non-repetitive, which is where the per location stuff comes in. Yeah, the same thing would apply to the rivers, because the rivers use tiles. There's actually... so one thing with, like, the Unreal water system and shit is that their rivers and their oceans and their lakes and whatever all have different materials, and then they have to, like, blend them together using... I think they use, like, fucking render targets or something for the intersecting points, which is so dumb. I hate that. Whereas mine is a lot more, like, global. Like, what makes a river versus the ocean is that the river has this thing drawing velocity to the RVT in it. So, like, I could put this RVT velocity thingo in the lake, and it would, you know, I can just get the whirlpool and put that in the lake if I want. And then whatnot. Collision distance field for luminous huge cost when you have ISF to match separately after spawning them. Not a problem for water though. Okay, yeah. Yeah, these won't be casting shadows and stuff, at least. Although I guess they might be contributing to the thingo, right? Wait, where's the whirlpool? Hello? Huh. Are you not drawing to the... Run time, prismatic water data... it's not, it's drawing... fuck, what's this called? What is the thing called? What do they use for RVTs? It's something fucking dumb. Translucency. Translucency sort priority. Let's put you last. No? Is that it there? Is that it doing its thing there? Or like, what's the... I see something. Oh no, that's just a rock. Why won't this draw its velocities to the dude? I don't know. Anyway, it should be drawing the velocities into the thing, but whatever. Virtual Life Center where you can alter colors, characters, not usual places or regions. Yes. I could set that up to be done in RVTs and then you just place down, you know, regions and whatnot. So yeah, like these things just draw to an RVT, and then the simulation samples the RVT and does stuff. So that's how we can tell this lake that it is indeed a lake and not the ocean. Although the coastline should... Oh, right, I hid that. Coast spline. Bam. Okay. And now it knows that it is an ocean. But we can also make it, you know, still turbulate. And that has, like, smooth fall-off and blending and whatnot. So... yeah, it could be done that way, or you could do it with just, like, a big render target, which would be cheaper to sample in the water material. But yeah, totally possible. Totally possible, and you could... I could do it so that... it's just a matter of running out of channels. But you could do stuff like... you know, make the water more viscous in this area versus that area. But that would be a little bit scope creepy, you know. Little bit scope creepuous. Okay, so... Ocean. How the fuck is this gonna work? So we need to generate... We would have a... we'd have a thing. And that thing would have stuff. And then the stuff would need to do things. Let me just, like, pump up a fucking mega ocean real quick. So yeah, we could have multiple islands. Those islands would have their own coastline. You know, distance fieldy sort of dealio for their shore waves and shit. We wouldn't want to put tiles. Ideally, we wouldn't want to put tiles under the landscape. That's just like an accident waiting to happen. Although we would want to give it some clearance. Like, we'd want to be like, okay, like, you know, go to here at least. So that they clip in a little bit so that they can, you know, when it's simulated, they can ride up onto here a bit. So we could use... We could use the coast definer as like a culling zone where not to put tiles. Potentially. Those screen space reflections? I don't think there's any reflections at the moment. I think this is just lighting. Just, you know, directional light, low roughness, etc. Oh, maybe there is. Oh, yeah, no, maybe there could be. It's hard to tell. Maybe. I don't know. So, okay, we'd want to define an ocean bounds, right? And then... So this would be our, like, ocean tile bound, like, playable ocean boundary. And then we'd probably just chuck in some, like, fallback, you know, dudes on the outside that are just, like, fucking as big as the skybox. Right? You can be, what, like, fucking 2,000 big and 2,000 big. Go higher, 3,000. 3,000. Just, you know, on the edges, get like a big ass thinger that goes all the way to the, like, the literal horizon. Looks fucking terrible, but whatever. Oh yeah, look at that pixel, that DDX DDY moire effect. That's exactly what we want in an ocean shader. Okay, we'd probably, like, have a different, maybe a material thing that says, hey, don't do these things. I mean, realistically, if the ocean isn't completely flat, then the WPO should prevent you from seeing the bits. I don't know. It's a funny cloud. So yeah, we'd want tiles within the boundary. We wouldn't want tiles underneath landscape. We could do that by traces, or we could do that by, are they overlapping with the coastlines bounds? We could do it up to this inner spline line here. And just be like, oh, is the distance from the center of the tile some distance away from, you know, the outside of the spline loop? That'd probably be the cheapest way of doing it. So we'd have to get all coast identifiers within the bounds of the ocean doodad. Because, you know, we might have multiple islands. And preferably islands that aren't fucked up like this. So let me just put down just a dummy mesh. It's gonna be fucking... It's not gonna look like a thing, is it? The landscape material. That's a cool looking island you got there. Very swag. So yeah, anyway, if we had this there, then fuck. Why? Oh right, it's not in the RVT bounds. I'm silly. Time. Right, those are like... Okay, no, hold on. Let me just do this. We'll chuck them all over here, and now it has a coastline identifier. Cool. Socarius, bonjour. How are you? Okay, so now this has coast waves. I mean, it looks dumb because it's on a giant plane, whatever, but in theory, this is a thing. You know what? I'm going to put one in World Origin as well. Maybe I'll get one of the other ones. Got to think like a level designer. Do I have a P-scape like rocks material? Or stone? Rocks material. Ah. You know what? It's better than nothing. Fuck it. Let's go scale 10. Oh, that's a big boy. Where the hell is Z? Yeah, I'm doing pretty good. Is it true instead they say nor instead of no? I'm not sure. If I say no, does that... No. The answer is no. How do the Americans say it? Hey, man. No. 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 That's what Americans sound like. Sorry, Americans, but it's true. Hello, Lady Cat. What? What do you want, funny girl? Mm. Mm. Yeah. Hello, big chicken. Hello, hello. Come here. Have a big smooch. Oh, you're a big girl. Smell good. Happy? Yeah. Where do you want to sit? What do you want, my little gooner? You want my armpit? So goddamn funny. What is the matter? You're funny, girl. You're so funny. Oh, big smoochie. Big smoocher. Yeah. Hoppin'. Stop making biscuits on my tummy. You'll make me pee. What is it? You want to go outside? She wants to go outside and eat more rats. Oh, you should have seen the size of this rat that one of them left at the door. You guys thought the spiders were big in Australia. You should see our fucking rats. God damn. It's a monster. May as well have been a rabbit, hmm? Funny. Oh, I'm gonna sneeze. Oh, hold on. Ooh, sorry. I'm sorry. Oh. I've been abandoned. Where's the damn coastline? There it is. I mean, that's fine. Yeah, whatever. It's you know, it's how's it going? It's a bit how's it going? Where you going, Ladge? Ladge Cadge? Lagius Macagius? Now, my cats only respond to whistle. Like me whistling, like they're dogs. Or to me rubbing my fingers together. Or their names. Is this the fucking... What am I clicking on? That's just... What's that called? Plane 4? Oh, right, that's like the dude. Let me click this guy. And then click on this guy within this guy. The landmass mask. Let me make you bigger. Just make sure you're filling that little dude. Where were my runtime virtual textures again? Okay, they're this big. I can put like another dude over there, I guess. Yeah, I'll do some smaller ones. Why not? Smell of shrooms. Yeah, fair. They do... They are crafty, you know? The old catos. Oops. How you getting on with landmass? I haven't started yet. I think I might need to create custom distance field thingos. I might even need to do like fall off properly. Because like yeah, one thing that I'm running into is that the shorelines they can't overlap with one another properly. So like if you've got two islands close together and you want, you know, you can't really define the shoreline properly. I think distance fields would solve it to some extent, but not really. I don't know. I can figure that out another time. It's not important. I haven't done anything, Benny. I've just been fucking slacking this whole time. I'm slacking beige time. The other thing I can do is technically I can decrease the size of the mask. But that will just make the waves really short wavelengths. And move really slowly. Which isn't ideal. Stop slacking? Yeah, look, I know. I'm just such a slacker. I don't know how to stop. So yeah, I think what I'll do ideally is actually use geometry script to generate a distance field mesh. Well, generate a mesh, you know, like a distance field, but it will be global between all of these splines. So it'll still use these splines. But yeah, we'll be able to do something a bit more, you know, thingy. Finish your character, by the way. Almost. I haven't worked on it in like a couple of months, but that'll be one of the first things we do when we're back in Prismatica Town. Is do the characters, because I wanted to do a like a tutorial series on, you know, like procedural / modular characters. It's gonna be called a practical guide to modular characters in Unreal Engine. A practical guide. It's not gonna be like, this is how the pros do it, and this is how AAAs do it, you know, where they've got like 50 fucking people working on a character model. And it's not going to be like, just use MetaHuman. And it's not going to be like, oh, just use blah, blah, blah. It's going to just like teach. Like there'll be an episode about how to rip asset, like marketplace assets, and like edit them and repurpose them, and, you know, doing like data transfers and like fitting things to your character that you've gotten for free off the marketplace and whatever. Obviously not the whole thing will be revolving around that, but it'll be like, it'll be aimed towards not aimed towards programmers, but like it'll be approachable by programmers. So that programmers that just like, you know, they say they suck at art and they don't have eyeballs and they don't know what's good and what isn't, they should be able to like follow along and end up with something decent. Because yeah, it like, again, like I said, it's a practical guide. It's like, you're a real indie developer, solo developer. You're going to use, you know, free asset resources. You're going to want to take shortcuts. You're going to want to get lots of different clothing and stuff on your character. You're going to want to have like you know, a master character model, like master humanoid character model, and then all of your NPCs are going to use that character model, you know, like the Dark Souls games or like Skyrim and that kind of shit, where like, you know, all of the character models are the one base model with blend shapes for the faces and like bone scaling and all that kind of funky shit, so that you don't have to like repeat work. So that's what it will all be about. And I'll probably go through like, you know, weight painting for dummies. Like what is weight painting? How are meshes skinned to an armature? What the fuck is an armature? You know? Why do characters need bloody skeletons? I'm not making a horror game. I don't want skeletons. It's a joke. We all want skeletons. Right, so I want to... yeah, I don't think this LOD thing is going to work. I'm just going to set that back to... Fuck, do I have to get rid of LOD7. Set you back to there. You go there. You get delete. Yeah, okay. Cool. Where the YouTube chat lights go? I don't know. I think there are people in the YouTube chat. I know that for sure. I think the widget just dies all the time. Where is refresh? Refresh cache of current page. No? That didn't work. Maybe they are all dead. Oh no, there's one. Wait, who's that? Right, okay, no, yeah, it is working now. It must have just... done a thinger. Right. So ocean... So we need an ocean manager. What if people want oceans at different Z levels? I guess you just have multiple ocean managers, right? That's fine, yeah. So ocean manager, it will... I guess it will just register on construction. Well, no, I guess we have a function for generate ocean tiles. And that function gets called on construction, so we can see it in editor and shit. But then it can also be called at runtime for a procedural dude. So it is going to get all actors of class coastline fucko. And then it's just going to whack tiles down within the ocean bounds, except within the coast spline, man. Although... Yeah, and I guess in here... it gets a bit... Like, what would I do for this kind of thing? Like a bay. Where, like, yeah, the ocean waves kind of break here. But this still needs shit. I guess you'd just put a fucking lake down, right? And just make sure it matches the Z height of the ocean. Maybe these could look for the coastline that they are defined within. And do the opposite function. So that if you put a lake down, or a bay, or some fucking water body, who knows, that infringes on the ocean, it doesn't make duplicate tiles. It'll only do it within the coast. Unless you start doing shit like, oh, it's a fucking river that's flowing into the ocean. But in that case, it should be fine. Maybe. Yeah. Yeah. And then these boundary definers, they... they're just completely separate. They don't require anything to function. You're going to whack them down. The only reason we'd need these on the CPU is for just like CPU buoyancy fallback. So if you had the ocean is less fucky over here, you know, ocean multiplied by 0.5, if we were looking at a ship really far away, then the ship would know to take the final output of the, you know, the CPU buoyancy fallback and multiply it by 0.5. That's the only reason these would need to have an overlap box or a relevancy bounds. So that's kind of chill. I swear I had another one of these in there. No, that's just the one. Oh no, there's one here. What's this one doing? Right, this one was doing so. I don't fucking know. Whatever, you can die. Alright, so I think that's how we'll approach it. We'll have an ocean bounds, which is a square. We'll have, outside of the playable ocean bounds, we'll just have some fucking big-ass tiles that will have like a... I don't know. Do they even need anything? I guess we just don't need normals on them because the DDX DDY kind of falls apart. And then within the ocean bounds, we have a instant static mesh thinger. Now I'm thinking, though, do we want to, like... No, I guess if they're all batched, it shouldn't be too bad. Because at that point, it's just triangle count, right? Like is instancing, like, manual... I'll wait for the ad to finish before I quiz everyone. So what I was asking was, if you... Is there a difference in rendering cost, right? Let's say I had 1,000,000 cubes. Or let's say I have 1,000,000 ocean tiles. And I've got 1,000,000 ocean tiles, you know, spanning the whole fucking doodad. But they're all instanced together. And, you know, that instance has been updated. It's fresh on the GPU. Don't have to send that info through anymore. It you know, the GPU knows it exists like that. Versus having one mesh that has 1,000,000 tiles worth of geometry. What would the instances render better? Like, is there still an overhead to batching all of the shit? Aside from, obviously, you know, the triangle count increases, like that makes it cost more. Is there, like, some performance loss by instancing versus having one giga mesh? Probably the same. Okay, that's good. Because these tiles are going to get really fucking small. Yeah. Scene interface batch into F-mesh batch. Individual U primitive component, each one gets added to the F-scene interface batch into F. Do you mean if it's an instant static mesh? Like, let's say I've got an instant static mesh component, and it has 1,000,000 indices. Do those 1,000,000 indices, which is just, you know, transform, rotation, the other one, transform, thingo, does that... Does that cost anything? Well, I guess it has to iterate through that, but it's all... Elliot, you'd know this kind of stuff because you're smart. You've definitely outpaced me in the smart department. All that is one primitive. Instead of added one primitive component, you're paying more. CPU costs and the GPU costs seems to be doing instance rendering anyway, even though modern draw calls are cheap. As long as everything shares vertex buffer and material proxy to be the same draw. Yeah, okay. Let me go over my thing, right? So I don't want to do the whole you know, that Unreal Water plugin procedural meshing doodad. I feel like it's just simpler to use tiles and, you know, regular LODing. Like, that's just makes sense to me, right? And I give them a tiny bit of overlap so that we don't get, like, holes. Presuming that it's single layer water, you know, not like translucent water. But when it comes to, like, filling an entire playable world with these water tiles, like, yeah, what do is the question. I mean, I could just fucking, you know, let's just do a dummy version of it real quick. Let's just say we've got a water actor. Create child blueprint class. This is called Ocean Bounds. Bigger tiles further away. So I did have that thought, but that requires like computing stuff. And also, like, yeah, that would be like a hierarchical thingamajiggo that requires, like, some logic of, like, you know, checking distance or as we move, get the ones over here, you know, get the tiles over here, delete the smaller ones, and replace it with one bigger one. Which, I don't know if it's necessary. Because if the instancing cost is 0, update scene, improve. Yeah, okay. Do you know how? Well, no, okay. So I know that I know that ISMs can be LOD'd on the GPU. It's one of the settings. But, and I'm guessing that just uses the same, you know, stuff that MIPing uses. Like, all the shit gets an ID, and it has distance, and it sorts its shit out, you know, for the MIPing, and it just uses that thing to swap out the mesh with the lower LOD. Whereas if it was like, if you had 1 million instances and they were getting CPU LOD calculated, then it would have to, like, update. It would have to send that LOD information to the GPU, which would probably be the same as updating the transform of the instance. Is that what BVH is? I don't understand. BVH. BVH. What's BVH? Virtual. Is the V virtual? The H, I'm guessing, is hierarchy. The B is butthole. No, what's the B? Not sure. Bounding volume hierarchy. Gotcha. Maybe. I don't know. There's one added complexity that I was thinking about earlier, which is I want to swap the material out when we, as we traverse around the ocean. Because the blue zone... The blue zone is... That's expensive? Swapping the material out, you mean? Because, yeah, to swap the material out, then we would need to be clearing, like, destroying and creating from a different, like, set. From a different fella. Like, we'd have to do the thing. Render proxy on primitive component being flagged as dirty. Queued for an update on the render thread. Yeah, exactly. I do... So with the AAAA GPU AAAA, and I'm yet to actually test it, but you can do AAAs with a different material, and you can also calculate the AAAs on the GPU. And so I wonder if doing it that way, the GPU would have both versions of the material at the ready, and the GPU would be changing the LOD. And so it might work that way without having to dirty the whole thing because of being calculated on the GPU. But then the only problem with that is that the LODs are screen size based. Which, if I had, like, enough, I need it to be distance from the simulation center based, which is why I was leaning more towards a CPU, like tiles. Because the thing is, right, let me explain a bit, because, again, you're smart. You have the brain. So the blue zone is all material waves. So it's like there's 4 Gerstner waves, there's a flip book with the doodad and whatever. Just derived normals, This is for like the far away shit. But then the orange zone is computed inside a render target. Or like inside a grid. And then all the material needs to do in this zone is just read from a texture. And that's how it gets its WPO, and that's how it gets its foam, and all that kind of stuff. Wait, where's foam? It's in the velocity. This kind of stuff. Oh no, that's the actual water velocity. Wave velocity is the one I'm looking for. This one here. And so this gets queried for buoyancy. And also, the material in here just reads from this. So all the close water needs to do is just 2 texture samples, or 4 texture samples, and it looks like water. Whereas the stuff over here has to do, fucking location-based Gerstner bullshit, and it has to sample an RVT, and it has to do all this extra. So it adds like an extra 600 instructions. Whereas the water in here can operate on like 200 or 300 instructions. Which is good. Because if we're sitting here, then vertex shader wise, this is like dirt cheap. It's just a few texture things and whatever, and the far away stuff is already like LOD'd down to infinity. So, and we need to compute this anyway for multiple reasons. We compute I call these emulated waves, and then the emulated waves drive the simulated waves, which are these ones. So the middle section here, the middle third, is the simulated zone, and the emulated waves drive the simulated waves. That's the pink zone. Pink zone simulated, yellow zone emulated, and the blue zone is the fallback. And so yeah, like if we're standing here, everything within, well, by default it's 40 meters here, so that would be 40, 80, 120 meters, can just sample a render target for their buoyancy. But yeah, so I want to swap out the material so that this stuff doesn't have to run the Gerstner waves under the hood. Because like it doesn't use them. It uses the render target, which the render target's doing the Gerstner waves, but it's doing it at like a lower resolution, and we get the nice, linear interpolation. It just ends up being, cheap. Or cheaper. So, material swap out based on distance without needing to... Well, the other option is to have... this is what Hellcat was saying, is... And I think Mydrung was also saying that just having them in batches of like, 10 by 10 squares, so that, even if the primitive thingamajig gets dirtied, it only has to update 100. It only has to send through 100 new values to the GPU of like, oh yeah, this one is using that, or like, we can create and destroy or swap out the ISMs within, kind of batches. And that way, like, I don't know, we'd still run into like draw call-ish issues depending on the size. But I mean, at that point, I could probably just swap out any of like the far tiles. I could just fucking swap out with like a single. I could have like a big, I don't know, like a really big one that just manages all of the ones outside of a distance that maybe only has like 100 tiles that are this big, that can be updated on the fly pretty easily. I don't know, it's all a fucking... I've got no idea. And then the ones outside of the ocean bounds would just be, yeah, like one big tile just for the horizon line stuff. I don't know. It's scary. I'm scared. Yo, Niagara Falls? Whoever from Interstellar could be possible? It is. You would just have to change the wave formula. The Gersty boy. But yeah, I don't know. This is a thinking stream. I haven't actually done anything in the past 4 hours 20 minutes. And what's going on here? What did I... Oh no, that's just wetness. That's fine. Yeah, it's a tough one. It's a tough one. Maybe multiple ISMs. So that, yeah, like the dirtying cost isn't as crazy. This video series, why does the water glow? I'm spawning hundreds of thousands of particles in it. Just for fun. Just to see how, like, a GPU buoyancy for particles would go. Well, those ones aren't happy. Oh, I guess they're on the... Actually, hold on. What are they doing? The ones that are getting caught. Right, they're just off the water. So they should be culling, but... Yeah. Whoa. It's a river of blood. Yeah, that's cool. My eyes. What do you want, boy cat? What do you want, you little shit? Boy cat smashed a glass last night. I wasn't very happy. I'm not happy with you, boy. Brother boy. You little shit. Yeah. Suck on, suck on. Suck on, sucker. Hey! Stop that. Whoa! Look at that. Look at that texture space interaction. Wow, that's crazy. Who would have thought that you could, like, interact with textures? Nanite enjoyers be like, why don't you just make the tiles have geometry? Blowing it all around with the wind. We're winding it up. Actually, you know what? Let me do this. Yeah. Now we're talking. Yeah. Oh my god, boy cat. Shut up, brother. You're so annoying. The water... the water mesh looks so dumb when it's, like, hidden under the ground. Look at it go. It's creeping up. Creeping on, creeping on. Yeah, I don't know. It's... yeah. I guess I just have to do a method and then profile it, and then do a different method and then profile that. But I do think the material swap out. Like, let's check the dude. Here's your material. What's the damage? It can't even calculate the pixel shader cost, apparently. Excuse me. can you, like, just... Can you please... Alright, let me do, like, a recompile. Do that. Those are the words I would never touch again. Yeah, I mean, yeah. That's probably what I would do too. Okay, so the... Okay, but with this... I saw it, it was like 2,000 instructions. Okay, so 1,909 pixel shader instructions. And 839 vertex shader instructions. That's with both the fallback and the, you know, in simulation shit going at once. If I disable the fallback, you know, I'll do a little. Let me do a static switch. Oh, no, fuck off. Static switch. Switch param. Switch param. Fallback question mark. If fallback, then... fuck. Guess the phone. Where do I want to I guess if this is 0, if is fallback false, do this, then... I probably want to do it as far forward as possible. So don't do this guy. Don't add that in. This shit here, I will terminate. So bam, bam. I could do it here though. What else? No. It's better to do it later on. So this guy here, you're gonna add 0. Cool. This guy, what else comes out of here? You get added into some similar ZWPO. Some of it will need to run both. Like the transition zones will have to do both. Which is a good point. I probably need to... Well, yeah, it'll be fallback question mark. What the fuck is wrong with this cat? He just keeps, like, knocking shit over. What do you want, you little shitlord? He just knocked over a box of cat toys. Yeah, I need to put him outside. Probably it's nearly 5 a.m. He needs to go. He needs to go hunting. He needs to go let some steam off. So that's doing that. This is then... Okay, no, you know what? This could then go into there. Mask B. Oh, no, that's already getting fucked off. So... But that's post-perturb the dude. So I guess you can just go there, whatever. It's fine, whatever. So with no fallback stuff... and also the RVT, Ocean Multiplier, Lake Multiplier, also doesn't need to happen. Will this math get mathed out? You know what? I'll just fucking... Bam, bam, bam. Ocean Multiplier, just 0. I don't care. Fuck you. And then you... Fuck you, fuck you. Get that, do that shit, yep. Alright, so now no RVT sample, in theory. It should be all getting culled out. Oh no, RVT velocity is also... Oh, but then it's like, where am I using this? I mean, yeah, it's getting put in there. Multiply, that'll get multiplied by 0, so that'll get optimized out. That would get added. That's all fine, and the rest of the flow map does matter. So then this would need to do that probably, and then the other thing is this bit here. Oh, it's just a nightmare. Which again, all of these masks only matter for the fallback. Because the masks all get computed in the render target. So that would be getting culled, that's getting culled. Base color gets culled. That should be everything out of the RVT. RVT's nuts. Okay, so now we're down to 1,200 instructions. And 332 in the vertex shader. So it's like 60% cost. Actually, I can test this by seeing if it works. Yeah, that works. Our emulated waves should still work. Yeah, cool. So sim waves still work perfectly fine. Emu waves perfectly fine. Fallback waves miss me with that shit. Not computing at all. Except for the... Well, no, this bit here. This little FFT fella happens on all of them. What do I call it? Microwaves. Yeah, that happens on every thing. Whether it's sim or emu. Yes, boycat. And then the macro wave flipbook should also... I guess because I'm... Eh? What is it, my boy? What is it, Bullius? Yeah, no, there would actually be another cost saved, which is the macro waves would be zeroed out somewhere. Just fucking fang a little zero into that, you know? Just... whoop. And now it would... Yeah. Yeah, even cheaper again. So... Oh, wait, no, this one still needs to go in there. Where the fuck am I? Oh my god, there's so much shit. Flipbook, phone mask, that only... whatever. So yeah, point being... The instruction count goes way down in here. Obviously that is offset by the fact that we're fucking, you know, computing it all in a texture. But whatever. The other thing is, right, if we're standing here, like, you can't fucking see that far anyway, you know? I guess if you're on a ship, then maybe you can. Or if you were just up on here, you could definitely see where it starts and ends. Gotta get you to try my material graph one of these days. Oh. Why do you have your own material graph? That's nuts. That's like me level stupid. Sorry, I'm just picking my nose. Oh, in your engine. Right. Gotcha. Is it kind of like, aside from like the UI aspect of it, is it kind of easy to like set something like that up? Because like material graph is pretty much just every node is like a function that just has an input and an output, and you just string that all together like under the hood. And then I guess you'd... How do you deal with like Or do you deal with repeated code, like optimizing? Like if I use 2 nodes that are doing the same thing, do you, like, does that get compiled out? Add water input to water sim. Ah, that's the bit that I'm not doing. Classic. Oh, but that's not using a dude, is it? That's just using a raw dog input grid. That needs an input grid reader. Wait, where's that popping out? Here. Water input, sample previous dude, Sugma. Alright, so if I go to grid reader, grid collection reader, input grid reader. Let's schmacko you up with Jacko. Oh, no, up the other way. There you go. Smack this guy over here. Sample a fourther. Bam bam. Schwam. Water input. Get another guy. Sample float. That's not it. Sample float. Water. Reflectors. You go in there. And then you go into there. You can die. You can die. That should all get chucked in. What the fuck is happening? What are you doing, huh? What the fuck? Oh, right. No? Why have you frozen? Bitch, what the hell? Right. We're getting a ghost error. Emitter name is Pscape. No, what's it called? Sim input. It should be called Pscape sim. Sim input. The DI name is input grid. Bam bam. Bam bam. Alright, that should all work now. Hello. Compile, save. Okay, that should work now. Sim input. Right? Oh my god, what the fuck is this cat doing? Okay, now it's working. Cool. Oh. Now we can input velocities from our dude. Alright, I've got to go sort this cat out, because he's been a fucking menace. Him named Dennis. He a menace. His name's not Dennis, it's a boy cat. Let me just run an ad real quick, and then I'll read your response, Elliot. Hello, I'm back. Hello, back. Ha 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 ha. Two generic functions, one for definitions, one for declarations. Like a textual sampler node will steal and hold an index in the global sample array. Several other dynamic nodes. Everything's just pulling from a large structure. Everything else basically just writes GLSL directly in place. Or is base shader. That's a test replacement mode like material parameters. Gotcha. Okay. I'll basically run through each node after something topologically. Write the declarations like vec4 node, blah, 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 blah. Node samples more than once. It's just the same as reading it from a constant, so you don't have to do as many optimizations as you think, as do compiler graph and GLSL. But another actual shader compiler, which does the actual optimizations, which folding can't say. Yeah, okay. So there's kind of like two passes of optimization. One of them being like, well, yeah, like let's say I've got a node. And this node is going into this guy and that guy and that guy. Which I also... Wait, why are you going absolute? What column height? Yeah. Yeah, but stuff like, yeah, this node is going into multiple places just as easy as declaring a variable, like local variable, and then thinging it. Everything knows pixel shader stuff right now? Gotcha. Yeah, it's kind of, I mean, like, yeah, obviously they're completely different things, but it's nice that the Unreal one, yeah, is just like, you can get a texture sample and plug that into the base color, and it'll sample it at the pixel level. But then if you plug that into the WPO, it'll sample it at the vertex level. Or you can, vertex interpolate it or whatever. But yeah, I like that it do that. I like what it does do. There's a lot of stuff that like we take for granted with Unreal, I guess. Among the many frustrations. Reflect. True. Is it screen space reflections? Screen space reflections, how does that even work? I guess you'd just get the reflection vector and, like, sample. It depends on the fucking tilt, though. Oh, right. Like, okay, like code reflection. I getcha. I thought you meant, like, like graphical reflections. What the hell is that water? What isn't the water? It's full of bugs. SSA, I mean, that's a start. This is quadruple A water. Quadruple A LMAO. Should probably turn all those fucking particles off. Wait, actually, let me just double check quickly. Stat Gipu. Okay, so running that many particles is only like an extra half a millisecond. I wonder how many that is, though. It's definitely more than, like, 1 million. Yeah. Alright, let me turn that off real quick. New water. This guy. Goodbye. Now we're just left with the raw water. Just raw water. Raw, unfiltered water. Raw, unfiltered, strawberry-flavored water. You know? Kamikaze Fish Simulator. There you go. That's a new one. What pH is the water? -3. Right, I've got an exploder sitting here. Cranberry water? True, true. Where is the advection? Foam advection multiplier. Don't advect so much, you stupid foam. Foam mo. I should probably foam generator. Oh, that samples velocity. Oh, that should probably just get done here, right? Before that gets fuckoed. No, it should get done after. Well, but it's using the previous foam. Oh god, I don't care. I'm beyond care. More foam, more foam. Less foam threshold. More strawberry milk foam. Milk simulator. What's the foam decay rate? I guess it's this. Yeah, I don't know. My brain's... I mean, I told you guys I was sick, right? Right? Didn't I? Right? So what have we thought about so far? We have thought about Tile Manager. Ocean Tile Manager. We need to figure out the... Oh, fuck, I don't know. We have to figure out the cost of updating, you know, instances and shit. And where there is a good... How... Okay, what if we did something like, for example, Will the water sim run through pipes or aqueducts, maybe run into each other and stuff? Currently, the water can only have one vertical level. I have thought about doing 2 levels. So you could have like, you could have an ocean, and then you could have a pier over the top of that, and that pier could have puddles on it, and those puddles could run off into the ocean. Or same thing with a lake, or same thing with, you know, the landscape, and, you know, a secondary, like, yeah, an aqueduct or something, with, like, you know, with an arch underneath it. But keep in mind, this is all just visually simulated. I mean, like, it does work. Like, you can get buoyancy info from in the pink zone, in the simulated zone. But water from over here isn't simulating. This is fallback water. Let me actually go back to this thing and just turn the fallback on again. There we go. Let me just compile. So the blue stuff is the fallback. The orange stuff is emulated water. And the pink stuff is simulated water. And so, like, the system isn't really supposed to be used for, like, you know, you can't simulate with this system water running from a pipe over here, and down through a pipe, and then coming out here. It wouldn't, like, physically simulate that. You could emulate that yourself by having, you know, you could have that pipe drawing a mesh to the RVT, which, you know, denotes it as being water. And you could raise and lower that amount at different sections, you know, depending on gameplay logic. So you could simulate that in the gameplay side of things. You know, the same way that you would simulate flowing fluids through a pipe in, like, Factorio or something. Or, like, a conveyor belt, whatever. And then visually represent it using the plugin. You know, around the player scope. Does that make sense? But yeah, you can simulate the look of that happening, but not the actual long distance movement of water itself. So yeah, I think for the tiles, we could do... So the only place that we need to, like, frick around with changing the material out is around the player. I'm thinking if we just do, like, a kind of... Let's say, like, what's for... Fuck, we could even do, like, almost like an Octree style fucko for it. Where it's like, you know, like a 4x4 or like an 8x8 tile per instance. Or maybe even 8. 8 might be better. What's 8 times 8? 64? That's, like, totally fine to chuck into the thingamajig. Oh, also I'm missing the... Oh, no, I put that back in. Let me calculator. Let me do some basic math. 8x8. 64. So if we had 8x8 close tiles, and so an 8x8 tile set would be one instant static mesh component. And, you know, if let's say there was like an ISM here that was like kind of intersecting with the shoreline, and maybe it just doesn't have these ones, right? So it's like hierarchical. It's hierarchical, it's instanced, and it's static mesh, but it isn't a hierarchical instant static mesh. I wonder... Nah, I don't like that. Because then that... Hisms have to get, like, baked and shit, don't they? No, I want this to be, like, run-timeable. I don't know. I've literally never used or looked into HISMs. I don't even really know what they do. What does it do? I don't know. Do I care? I don't know. Why are these waves moving faster than these ones? I think that's because I was testing something. And I did something silly in the wave guy. Shore waves. Time. Wave time. Yep. There it is. Did I do that in ocean? Wave time, blah, blah, blah. I didn't. No, it was just with the shoreline. Cool. I didn't even fucking notice. Okay, so we have... So, like, the cost of spawning or moving an 8x8 instant static mesh doodad. Probably not. I could even... What happens if you hide an instant static mesh? That doesn't have to send through a bunch of data, right? Because it's just saying, like, oh yeah, hide this. Hide this shit. Or, like, it just has to send it to the one dude? Like, it doesn't have to adjust the array. And then if you want to re-enable, like, unhide it. Hold on, I might be cooking. So yeah, if we have our big tiled fellas, and these are like one dude per dude, and then at a distance, we swap out these tile sets with one big tile, which is part of a bigger thing. Or... Yeah. As long as there's not, like, shit tons of these guys, we can, like, pretty easily add and remove these instances. And yeah, like, it's gonna have to update, what, like, fucking 50, 64 tiles, maybe? No biggie. They could even be partitioned as well into, like, 64 by 64s. So then if we're sitting here, we then, you know, rejig this tile, or this instance, index, just fucking yeet that out of the way. Remove it. It updates, it, you know, gets dirtied, it does its shit, whatever. And then we just unhide the tile ISM that is occupying this location. That should work, right? That way we can just hide and unhide the more complex dudes and regenerate the bigger, coarser tiles by actually, like, you know, adding and removing them. Because, yeah, you can't just set visibility of one fella. Instant static mesh. You know, you have to remove instances, visibility. That's toggle visibility for the entire component. Which doesn't have... that doesn't have... that's for, like, component attachments. Okay, that might be the solution then. Because that means that the far away tiles will be fallback only and not sample the render targets and shit. And then the near ones, which have their, you know, their kind of tile locations all fine and whatever. You know, not having tiles underneath the coastline, that kind of shit. They just use the other material. Now, that might only really apply for the ocean, but it might not even matter for something like a lake. Like, I don't know, this is a very small level. What would I do for ones here, though? Well, I guess in the case of, like, a lake, we could just fucking swap out the, we could just update, you know, add and remove instances for the material swap out and that kind of shit. If it's not, like, that big. Because, yeah, the only thing about lakes and stuff, if we were to just swap it out with, like, a big-ass MF like this, then... oh, well, no, maybe we could just swap the entire instance cluster out with the other material. With the fallback. And then, as we get closer to it, it becomes... well, the cluster that has... the fallback and this, like, you know, the kind of crossover zone would need to run both materials. Right, because we want the ones that are, like, in here. Like, we essentially want all these ones to not run the fallback shader at all. But then again, I guess these ones are like, you know, yeah, a 64 by 64. Oh, sorry, a 8 by 8 tile size. So that can just swap the material out without issues. And it's only when we're, like, super far away that we then hide that entirely. Yeah, I think that's the way to go. Let me write that down. They'd be called cluster pairs. Oh, we'll call them duo clusters. To swap materials. Ah, that means I have to have... well, okay, no, that means that, like... it'll only ever be... well, yeah, like... if the thing only has Oh, they might have to be like triple layer. Triple layer to swap material. What are they called? Material permutations. So fallback, transition, and simulated. When a cluster is fully out of the zone, out of scope, we hide the ISM and replace it with a giga. Oh, well, we either hide the ISM and replace it with a tile from the Giga Ocean ISM, or if it isn't an ocean, we just replace well, I guess we just leave it as is, fully fallback-did. Fully fallback-did materialed. Yep, so LODs are all handled on handled on GPU, separate from material scope. Draw calls are not too bad because of the far ocean giga ISM thingo. So it means at worst, water tile manager. At worst, in our simulated and fallback scope zone, we have how big's this? 1, 2, 3. So we'd be fucking around with like what, 64. That'd be one extra. Maybe even 4x4 clusters would be fine, because that means within our doodle dick zone, our sim zone, like, that's like what, 4 draw calls? I guess we'd have to have these guys as well. Maybe 5, but it depends on the fucking thingo. But yeah, anyway, like, yeah, even if it's 8x8, and we have like wasted stuff out here, that it still would be using the fallback material. But we just have to keep swapping them in and out. There'd be 3 instant static mesh components per like octo tile, 8x8 tile. So we can swap the material out so that we can save rendering cost at the expense of needing to, dirty and send through the data for, the instant static meshes, which I think at this scale, like a maximum of 64 indexes per instance, it's like, it's kind of like, who cares, Well, no, that's the thing, right? It wouldn't ever be it wouldn't be updating all 64 at once because we would have 3 instant static meshes. One of them is like, you know, this is like in the complete clear. So we'd have what, like 8, 4x4, 16 in here. And then the transitory zone, you know, might have like another 16. So we'd only be updating kind of like, do you know what I mean? Because they'd be broken up into the 3 different ISMs. And so then the update cost is pretty negligible. And that would be happening for probably like, so that's an 8x8. And these are, fuck, how big is one of these? I guess we'd figure that out. But we know that the simulation size by default is 4,000 units, 4,096 units across. So we know that everything outside of that 40 meter, you know, zone is fallback. So if we're not, you know, like the big tiles, we can transition to them pretty easily with that in mind. Obviously that would be dependent on, yeah, that kind of shit. Human, it's flowing. It do be flowing. That much is for certain. It do be flowing and it do be glowing. Well, except for the ones that are like void black, but you know how it is. There we go. It's a bit nicer to look at. Oh my god. Yeah, I'm currently just trying to nut out. I'm just trying to nut the just like some back end shit. Like just turning this, you know, from a tech demo into a you know, into like a usable tool, basically. Let me just go to my foam mo. Is it just not dissipating quick enough? Yeah, I think that's it. Yeah, it's a whole thing. It's just you know how it goes. It's just it's funny with the grass that's under the water. Getting swept up by the waves and shit. Silly. I mean, it's funny. It's not supposed to. Well, I mean, it is supposed to do that, but it works with seaweed. Seaweed simulation. Oh, it's getting dark now. Oh, hello, Rick Turpentine. Sorry, oops, that was my bad. Yeah, okay. Yeah, so I think for the ocean stuff, it's pretty chill. Because yeah, in the ocean we can see heaps of it. So if in the ocean we maintained our little cluster thingos, that would be one draw call per, you know, per tile, which ends up being like, you know, potentially like hundreds of draw calls, which we don't want. So we'd convert these ones to the fallback, you know, far distance ocean ISM tile. And then for the nearby ones, we would, well, they'd still exist, they'd just be hidden until we delete the fallback tile and unhide the, you know, the tile cluster. Yeah. Can I just, like, delete these at runtime? Oh, yeah, I can. Oh, fuck. Sheesh. There's a hole in the ocean. I can't move them. They're not set to movable. It's kind of cringe. I know that one of these is movable. Yeah, I can totally do that. Zoop. Whoa. Yeah, the particles look kind of dope. This will definitely be in, like, the sizzle reel, you know? Like, whoa, interactive motherfucking millions of colored funny particles that are destroying the bitrate. Wait, that doesn't have collision. Cringe. Oh! Okay, that's the wind explosion bug. I don't know why. It's just a divide by zero feedback, isn't it? Whatever that means, you know. Whatever that means. Sorry, I'm just playing RuneScape. All right, so I think this is good. And then for lakes, we just leave the lakes as, like, clusters. We don't really need to bother with giga clusters. The only problem with the lake... Oh, maybe I could have, like, a tick box that's just like, oh, yeah, like, use fallback big tiles. The only thing is that with the big tiles... You know, if they're, like, fallback... If these are all one big ISM, which is cool, for draw calls, then for something like this, or, like, you know, a really, like, wonky... How am I trying to put this? Well, yeah, we just don't want to, like, replace a water body with... You know, let's say this was set up to be... It's like smaller water tiles in... Is that rotated? Oh, yeah, fuck, it is. Alright, whatever. Let's just say this was set up to be like... You know, it's nice and high res. We can do, like, our bullshit with it. Whatever. I'm gonna undo all that. But let's say it was, like, in a wonky shape. And it's on top of a hill. We wouldn't want to replace... this with, you know, a fallback tile that's like this big. Because then it's just like dumb as fuck. We'd want it to maintain its shape, which means it has to always be a tile set. Yeah. And then I guess for like really little ponds and shit, we could just generate some kind of... No, I mean, these tiles are pretty small. It's like, what, 4 meter? 4 by 4 meters? I don't know. Could I carve out some vertices to fit the surrounding lake? Yeah, no, I could do that with a procedural mesh. I mean, this is more of a pond, right? Whereas, like, a lake is, like... I mean, in real life, a lake is as big as this island. And so, for a water body as big as this island, we'd probably want to be using... Oh, well, no, even then, like, something as big as this, it's like... Again, if it's in 8x8 clusters... That's like fucking 4 draw calls. Like, who gives a fuck? That's nothing. Most people are going to have more draw calls in one fucking character. Let's be honest. They're going to have a material for each fucking eyeball. So I think having like 10 draw calls for a lake is fine. Oh, also, do you want to see a cool trick? Cool trick. This is totally tangential, but I figured out a really funny trick for doing the like if you've got a boat and the boat needs to cull the water, I have like a 0 cost solution. Draw call is a buzzword. From my experience, draw calls is like... It actually matters. Like, when I was doing... I mean, for static meshes, you know, they can get... They can chill out, whatever. But when I was doing, like, character stuff... Like, even if the pixel and vertex shader octupled... Even just reducing 3 draw calls was like... You know, when you've got, like, 200, 300 characters on screen, it actually, like, doubles the frame rate. It's pipeline switching that hurts? What do you mean pipeline switching? I mean, I've done, like, profiling where, you know, you've got 1,000 cubes, and those cubes just have 8 verts each, and then you turn off the auto-batching, and the frame rate just fucking tanks. So, I mean, there's definitely... there's, like, a limit. I'd say. Like, up to a certain point, you can kind of get away with it. But, like, past 1,000 draws is, you know, danger territory. Unless you're using nanite, in which case your frame rate's probably 30 FPS anyway. So, you know. Also, you got to remember, not everyone has modern hardware. I'm using a very outdated 2080 Super. It's like a dinosaur now. I've been left behind. Right, I was going to show you this funny trick. It's going to be called Water Hole. And I'm going to put it on a Sphere. Do I not have spheres? Sphere. One appears when... okay. Each individual material generally graphic pipeline, switching graphics pipeline. PSO is really expensive. Iterating on each draw. The most expensive part is just iterating on each draw call on the CPU. Gotcha. Right. Alright, let me show you a funny trick. Yeah, right. Well, I wonder at what point on modern APIs that pixel shader cost or pixel shader complexity and vertex shader complexity outweighs draw calls. I'd actually love to get like actual numbers on that, like pixel shader complexity versus an additional draw call. Like how many, instructions is a draw call worth per pixel screen space, I guess that's the other thing, is that people use like a separate material for the 150 draw calls that are literally not... It's like City Skylines 2 with the teeth, with the character's teeth without LODs. I think that should be... I can't remember if that's 0 or 1. Oh, was there an ad? Did you get adged? Oh, I crashed. No. Oh, maybe my internet dropped out for a second. Can I do... No, that's unlit in there. Oh, the fucking TAA. The TAA. You bitch. I'm sure that's fixable, though. Anyway, yeah, this is my trick for masking the water out of a thing. You just have another single layer water material. Right, I think my stream did restart, actually. I think my internet. It's very windy outside, so yeah, probably did. But as I was saying, for like boats that are in the water, you can just put a single layer water with 0 opacity over the surface of the boat. So fucking dumb. Rather than doing like, some kind of render target thingo. What do you reckon? Cool trick or not cool trick? I don't know if I'll actually use it, but because like it's in the name of the shader, single layer water. So if you just put some water with 0 opacity in front of the water, then like it's totally chill. Although you would run, let's say the boat was like here. You'd run into like this kind of thing where the waves go over the top of it, like that. But you can then use the camera offset function to do WPO on it so that it sits without changing its like screen position. I mean, let me just grab like some cubes. I'll do a cube version. Where's the damn cube? SM cube, cool. So this would be like a flat thing here. And then we'll do just like some kind of P-scape rock. Yeah, whatever. 1. Let's do that like here. 2. Where the fuck does that start and stop? And then zoop. And then shoop. And then whoop. Right, so we've got our hole. But the water is clipping over the top of it. But then we use camera offset to just bring it closer to us. Although we get some fucked up shit like this. Oh, and the smearing is affected by that. Okay, maybe not that far. Maybe we do like this and we'll bring it up a bit and whatever. Oh, right, no, that's why, because it's not covering the whole dude. Anyway, it's a funny idea. You can just mask out water, and this could be we could do masked material, and we could get the Charlie texture and put that into the mask. So this could be like the shape of the boat, you know? Oh, it's fucking two-sided. Whatever. So yeah, we can cut out like a person-shaped hole if we wanted. But, I mean, ideally you would just have a mesh that is the exact shape of the boat that could mask it out, I guess. Although in my case, in the case of this plugin, yeah, no, it would still be useful. Because we don't actually do, like, upper and lower distance field exclusions. We just alter the water by, like, you know, the interaction velocities. So it would actually be useful in here. Right, let me have a gaze. Alright, it's 2 images. So top one is 100 instance meshes, and that one's single mesh. Oh, as in like one big mesh with the same triangle count? Oh, wait, no, okay, right. This is just one single mesh, and this is 100 separate ones. Drawing the same thing. Yeah, okay, so that's just that times 100, but they're instanced. What's what about 100? The other is 100 draw calls. Okay. Are you sure it's not doing... Right, no, okay, so this one here is 100 draw calls. Which is this. The single is 0.02. It's 100 draw calls. Yeah, so this is single draw call. That's 100 draw calls. And they're all the same mesh. So what about like an instanced... Top is 1 draw call with the instant counts set to 100. But... Right. Okay. Cost of 1 single draw call. Okay, but so what's the cost of 100 draw calls then? If you did 100 separate doodads. Because, like, yeah, you could just multiply this by 100, but... this could... Yeah, do you know what I mean? I think at some point it starts chugging, though. Because I've found that, like, the first, like, 400 draw calls are pretty much free. Like, nothing really changes. You know, from 1 up to some number. But past, like, a certain point, it starts to just, like, you know, it starts to just get weird. More expensive than other relative CPU. Yeah. Okay. Well, yeah, that's the thing, is that, because that's why in stat unit, so right, so you're saying on the GPU side of things, draw calls are pretty chill. Why do I have a 0 draw? Hello? Am I just that optimized? Or is it because I'm frame rate capped? I don't know. I'm too fucking tired for this shit. But right. So the thing, because especially the API, for example, every draw call my API has to check. Okay, to the pipeline switch. Okay, to the descriptor set switch, but CPU set. You gotcha. Yeah. So Unreal classifies that usually in the draw. This draw milliseconds, which I guess is like, yeah, okay, pure GPU time, not dissimilar, but the overall game cost can chug. I don't know why this doesn't... Am I just that good? I don't know. What's the go? Draws are 400. Pretty chill. No, it hasn't peaked over 0 mils. I feel like this is broken. This used to be way higher. Although, am I using DirectX 12? What's it called? Fucking... What's the rendering thing? RHI. That's it. Wait, is that in project settings? No. Default RHI. I'm okay. No, I'm in DirectX 11. You know what? I will. Let's go down this rabbit hole. We'll get something done. Director. Yeah, I mean, you know, just chilling. Well, I mean, I need to make sure the plugin works. DirectX 11, you know. Need to make sure it runs on Nintendo Switch 1, Switch Original. Need to make sure it works in VR. It's chilling. Right, I wanted to uncap my frames. Edit, project, fixed frame rate. Oh, wait, no, I'm T.maxing. Stat FPS. No, have I been running uncapped this whole fucking time? Alright, so we've got like a nice little 90 FPS with... Okay, you know what? I'll turn these fucking particles off. They're getting ridiculous. I don't want like a trillion particles. Okay, so 100 FPS, pretty chill. I think this is actually... A lot of that's from the single layer water. Someone mentioned that there's an ini command, an ini outie for single layer water. I forget what it was, like 2 pass opaque or something. Anyway, so we've got 100 FPS. And then let me just put the man out of single layer water land. No, you know what, fuck it. And then we'll go close this shit. Edit, project settings, RHI, default RHI, DirectX 11, restart now. Hopefully I don't get a crash on startup. I'm going to have to recompile all the shaders, aren't I? Yep. Classic. I shouldn't have done this on stream. 73. Okay, no, that's not too bad. I thought it would be doing like the startup shit. Alrighty. Let's see what DirectX 12 does to my stuff. Oh my god. Oh my god, it's so buttery smooth. Oh my god, bro, that's fucking buttery. Actually, it does feel it. Okay, 100 and... Oh, fuck, yeah, I'm capped out. Fuck. See, like, my shit's just too performant. Okay, I am getting draws, though. I'm getting draw calls. Very interesting. Okay, so with... Let me just go back and then in... is it... Oh. Hello? Okay, interesting. Does... Oh, it probably needs to compile... No, this is work. Why isn't my... hello? Plugin? Something's happening. Hold on. All good, human. Have a good one. Thanks for sticking around. Where is Water Sim? Can I just recompile it? What the fuck is going? Hello? Why would just this part be angry? The wave velocity and stuff's all fine, but the water is not happy. I mean, we're getting water here. Well, that's okay. That's coming in from my. Oh god, it's sprung a leak. Oh god, fuck. I wonder what. Okay, I'm guessing something isn't happy with. I mean, that's all normal though. That's water velocity. Where's our water render target? This guy here. I'd say it's something to do with the water RVT. The water height RVT. Let me just like tickle that on and off. Okay, yeah, hold on. Okay, that was it. It was the water height RVT wasn't loaded, I guess. And now it is. I guess. The fuck are all these? Oh, that's probably because the... Yeah, where the fuck's all my water going? Why is it... Huh? I feel like that's floating point issues within the plugin. Water sim, handle rain stuff's turned off. Why are we losing water? Conway's game alive. I mean, hello? Why is velocity making it disappear? I don't fucking know. Anyway, I'm going back to DirectX 11. No, I wanted to check the performance. So running all of our stuff. Seems like it's gotten a bit angrier. Is that just because I'm moving there? Oh, hold on. Wait, what the fuck? Is that just input delay? That's input delay, right? So why are we at 60 FPS now? Draws 200, prims 300k. So, okay, hold on. Gipu. Niagara GPU simulation 1.6, so that hasn't really changed much. Unaccounted 1.2. Oh, wait, no. Game time, draw, 15 milliseconds. GPU time, 10 milliseconds. Memory's fine, draws. So, if we go back to edit, project settings, RHI, default RHI. I could try Vulkan. You know what, fuck it, let's just fuck around. We fuck around, we find out. Although my guess is that, yeah, Vulcan breaks a bunch of shit. This is so not worth it. I should have just stuck with DX11. I should have just fucking stuck with DX11. Alright, this will probably take the rest of the stream. But yeah. Right, well, I think I might wrap it up anyway. Just because I'm not really doing much. Vulcan's superior, though? I mean, we'll find out. We'll find out. I'm guessing what happened with the DX12 is that something in Niagara Grid. I mean, obviously something in Niagara Grid was a bit fucky. Or it was the runtime virtual textures, you know, not being loaded properly, or I don't know. But yeah, I'm guessing that Vulcan won't, like, some things just won't work. But it'll be interesting to see the performance boost. It was weird, though, because the going to DirectX 12, when I was just in editor, like at the start, it was like 20 FPS higher, but then as soon as I started playing and opening up assets and shit, it just like tanked down to 60 FPS. Which just makes me think something funny's going on. So yeah. Yeah, this is like halfway done. So Niagara falls over. Yeah. Niagara falls over with DirectX 12. Well, anyway, I'm gonna wrap it up. I think we'll raid first Crimson. Not Crimson Mana. The first one. Not Crimson the second. Or Crimson the 0th. We'll raid Crim. And I won't be streaming tomorrow, but at least we've kind of like brain squeezed a bunch of things out. I think the idea with, yeah, for the oceans specifically, having the big chunky fallback tiles is good. Also Dylan. Let's go to Australian futures. Let me scroll up. It might not have. Oh, here we go. Visual Tech Art on YouTube's newish texture channel Repacker. Seems like it'd be useful to use since it repack marketplace channels, since you use specific channels. Is it a standalone app, or is it using the new texture graph in Unreal? Because I've started using texture graph and packing channels that way, like in the engine, and that works really well. Like you can just split, you know, texture sample, split RGBA, reroute them, change the brightness, contrast, and whatnot, and then just render that as a new texture all in engine. So I'm guessing maybe he's doing a similar thing. Or, yeah, maybe it might be a standalone app. But I need to get back to doing videos, because there's a lot of stuff I need to, like, get out there. You know, Grid 2D basics, Grid 2D fluid sim, Grid 2D, you know, world space moving shit, how to get data into them, how to get data out of them. The whole character series I need to do, which I can only really start after the plugin update's done, because then I'll be working on Prismatica stuff, which means I'll be working on character stuff, and all that. And then, yeah, just other little things. I want to cover, Do you guys know Materialize? It's like an app that was made like fucking 10 years ago, but it slaps for like generating like normal maps from height maps, but also generating height maps from normal maps, and also just turning, you know, like generating normal maps from color textures and whatnot. But for like repurposing marketplace stuff, especially when like they don't supply a height map, you can generate the height map from the normal map to then be able to do height blending and stuff with marketplace textures and shit. So yeah, I've been using that like a lot for you know, for ripping assets. Sorry, for formatting assets that I own, that I paid for with my free monthly. Actually, what are the what's the? Sorry, I'm getting distracted again. What are the Fab limited time frees at the moment? Because they do 2 of them per month, don't they? 2 rounds. They used to do VFX melee weapon aura, conference meeting room environment, handy, abandoned hospital. Not really relevant, but yeah. So yeah, absolutely. Yeah, if it can do it on mass, then that's dope. Yeah, I wonder if it's using the texture graph under the hood, or whether it's using the old school like canvas render target thingo. Because yeah, you could set up an editor utility that like sets up a dynamic material instance, sets the textures and reroutes them, and just does it like draw canvas render target thingo. The only problem that I've found with using that and then converting the render target to a static texture is there's like heaps of quality loss. Whereas the new texture graph stuff uses like the raw imported textures and whatnot. Yeah. Texture graph, I know I always rag on like Unreal adding more features instead of refining old ones, but like texture graph and like the in-editor animation tools are like kind of cool. And I guess the in-engine modeling tools is cool because it hooks into the geometry script stuff. But yeah. Crazy to repack how you want. Select 400 text to repack them all to... Yeah, okay. Yeah, I wonder if it doesn't use texture... Because I know texture graph can be parameterized, so... But I mean, I guess I'll have a sus. I've got 72 shaders left to go, but... I think we'll raid. We'll raid on out. Raiding on out. Raiding on out. I will not be streaming tomorrow. Because Amethyst is traveling here. We're going to play RuneScape. We're going to get on that grind. But Thursday, Friday, Saturday... How many days left? I think I've got 4 days. Well, okay, yeah. Friday, Saturday, Sunday. I said I was going to get the plugin finished this month. But I don't think that's happening because I lost a few days to, like, sickness. So, you know. Tile Man, Iron Man? No, just Group Iron Man. Tile Chunk tile chunk region locked ultimate hardcore Iron Man. Vegan ultimate hardcore. Skiller? No skill. Drops only. Anyway, let's raid on out. And thanks everyone for watching. Hope you learned something. We didn't actually, like, do much. But at least we decided on some shit and just figured things out. And, you know, sometimes that is half the battle. Thinking... what's the saying? Thanks, G.I. Joe. Now we know, and knowing is half the battle. Alright, the raid... Okay, anyway. The raid just went through, so... Oh, you know what? I can do the, I can do the YouTube raid for the YouTubes. Let me do that real quick. View my channel. Click on this one. Go edit video. And, ow, that flashbang. Customization. Hello? Customization. What the fuck? Did my stream just die again? Edit video. Okay, no, I'm no. Wait, why am I no longer live? Oi! What are you doing? View my channel. We go to the current live stream, which is live. Edit video. What do you mean something went wrong? Let me fucking... Alright, you know what? Maybe if I go into the video manager. Manage videos. Videos live. Current live stream. Details. Then, okay, hold on. Oh, Vulkan engine's opening. Customization. Redirect. Jesus Christ. Alright. Videos from other channels. Suit for hire. Save. Okay, now I can finish the stream. Thanks everyone for watching.